Hey folks, can you all hear me okay? Do not envy the battle OJ will have on his hands to get it working. Yes, Linux and bells is always fun. Can you all do me a quick favor and let me know if the sound is up too high, too low, whether or not the text is too big or too small, just so we can get that out of the way now and then we can move on. Sounds good, thanks Justin, excellent. All right, that's great. Going to be doing some other stuff at the same time, but I'll be listening and hoping to learn something. Thanks, Mongo. Good to have you, mate. Right, so the plan. First of all, actually, there's two things that I want to bring up before I get started. First of all is I streamed Guy Baronia last time, and I wasn't sure whether I was committing a sin or I'm going to end up in a lot of trouble with copyright violations. So I emailed the guy and said, hey, I've been using your music on some streams, is that okay with you? And I got a letter back from him officially saying that I am allowed to stream his music whenever I like. So that's awesome, which means with a bit of luck we won't have any violations of copyright appearing on the likes of YouTube when I archive the videos off. So that's pretty cool. So I'll be leaving Guy Baroni running in the background, and if you find him annoying, then that's too bad. Secondly, for those of you who have seen previous streams of mine, you'll probably notice there's something behind me that's a little bit different. This was my birthday present, and it is a internationally certified competition foosball table. Yes, we take our foosball very seriously around here, so if anyone's in the neighborhood and feels like getting absolutely thrashed, feel free to let me know. Okay. The bells on my Ursi aren't working, so I will periodically check, and I'll keep my eye on my other laptop as the chats unfold to make sure that I don't miss anything. But I will do my best to check back in when things make sense or when things grab my attention. Right. Thanks, Mongo. I'm sure he does have a much better Aussie accent. There's actually a reason for that, because I was technically not originally Australian. Hacking without T is uncivilized. Development without T is also uncivilized. Yes, so Justin does sound a little more ochre than me. I have a very slight twang compared to him. Okay, so before we get started, what I really wanted to do with tonight's stream is to get everyone up to speed with Meterpreter development sort of in general. I'm not going to go into every single piece of this puzzle because there's clearly a lot of stuff in here, but what I'm hoping to pass on is the basic structure of Meterpreter, some of the components of Metasploit, and how those two things talk to each other. And while we're doing this, we're actually going to be building a new feature into Meterpreter that I've wanted to see for a long time. I'm pretty sure it's certainly possible on the Windows side. I haven't pictured exactly how it's going to work on the Metasploit side yet, and as far as other versions of Meterpreter such as the Java and Python and all of those things, really not too sure how those things are going to go. But I'm hoping a couple of Metasploit people will land on stream and help me out. Oh, there's one. Firefarts just rocked up. Hey Christian, thanks for coming out, mate. I hope you enjoy. So here's what we're going to do. At the moment, as you're probably all aware, when you get a Meterpreter session, you have the ability to add new extensions to it on the fly. There are common ones. The common ones that are loaded without you even knowing are Standard API and Priv, at least on the Windows side. And then from there you can add things like network sniffing or the extended API, or you can load Mimikatz or Incognito, and each one of these things is actually a separate DLL that's uploaded, injected into the process and run. One of the gripes that I've had with this process is you can't unload those things. And more importantly, as a result of not being able to unload those things, we can't scrub memory and we can't free the memory, which means that, let's say if you inject a Meterpreter session into explorer.exe, then close it, and then another one, and then close it, and then do it again, and then close it. Each one of those things leaves artifacts behind sitting in memory. And slowly but surely, if you hit the same process enough, eventually you're going to run out of virtual memory and things are going to start to break, which isn't particularly fantastic. So what we're looking to do tonight is we're going to make it so that you can unload extensions as well as load them. And when we unload them, we're going to scrub the memory clear so that prior to it being freed, RAM is actually set to 0. So I'm not going to scramble it or do anything like secure deletes or anything like that. But there will be enough, I think, in here to make things a little bit more forensically sound than they are right now. So that's the plan. Whether we get there or not, who knows? Along the way, I'm hoping you guys are going to learn something. If we don't get there, I'll follow on in a couple of weeks and finish it off. So I have the Meterpreter source code sitting up on my VM. This is a Windows 10 VM, and I'm using Visual Studio 2013, which is currently the officially supported version of Visual Studio that we use to build this thing. It will build on Visual Studio 2015 with some tweaks, but we haven't had the need/desire to adjust things as of yet. So Visual Studio 2013 is where it's at. So if you want to have a play with this, then be sure to get yourself a copy of the free desktop version of Visual Studio 2013, and you can build this stuff too. So far, if I just hop over here, you'll see that I've currently got I've got Metasploit Framework sitting in code Metasploit Framework, and I've got Metasploit Payloads. And with one single change, and that's in code Metasploit Payloads. And you'll see that like those two folders are right next to each other in the same location, and that's important later on because there are commands that you can run inside payloads that will allow it to deploy build binaries over to Metasploit Framework so that you can rapidly churn the changes that you're making without having to update gems and do all kinds of other crazy stuff. Okay, so the one change that I've made is to this line here. So when I'm doing dev, the first thing that I do is I open common.h, which you can find in the Meterpreter source common folder, and I uncomment that line. So you'll see that's usually how it is in the official source. That's exactly what it looks like now. I usually uncomment that. So when you build, all of the debug output capabilities that Meterpreter has baked in will actually function so that you can read debug as it's going. I do all of my development under 64-bit, so I only go back to 32-bit when I'm pretty certain that I've finished what it is that I'm doing. And you should be using the release build here, not R7 release, but release. Debug builds don't actually work. I thought I'd remove them, but clearly I haven't. R7 release attempts to build an extension, which is the sniffer extension. The sniffer extension won't actually build locally unless you have some proprietary SDK sitting on the file system. So for the general purpose of the open source community, release is what you should be building. Okay, so what I've done is I've modified this file, changed this so that this is actually defined, and I've done a rebuild. So basically it means that, oh, there you go, it's going to kick off again. So this is currently building the Meterpreter source in release mode for 64-bit. Okay. Now, as a little bit of a demonstration while that's running behind the scenes, I'm going to run SF console. I've got this little test resource file that I use to just spin up a bunch of handlers for different reasons. I'll let that kick off. and I'll show you what is listening when it's finished. So this is just a classic Metasploit resource file that you can fire up on startup. And you can see it's just setting up a bunch of handlers for me so that I don't have to do them myself. And then at the end, didn't realize there were so many. So you can see there's a bunch of them there, all different types. There's even a multi-payload now, which would appear down here, but I haven't got that wired in just yet. But now that they're running, let's go back to our VM, and I'm just going to kick one of these off and go back. So let's go into that session. We can see that we've got an active session. Okay. So this is where we can start using extensions. So you can type use and hit tab a couple of times, and you can see the extensions that we've got on offer. Okay. Each one of those maps directly to a DLL. So there's an Espia DLL, an Extapi DLL, Incognito DLL, etc. So if I wanted to use Incognito, that's what I would type, hit enter, and it says success. It actually says more than just success, but we've got a small issue at the moment with the console gobbling output, which is a little bit frustrating. As a result of running that, when we run help, you can see now that we've got some extra commands. Okay, so these commands were added on the fly once the extension was loaded, right? Okay, so with that in mind, what we're going to have to do is take a look at a couple of things. First of all, and this is how I navigate the source, right? I know that command load is the name of the command that's actually used, and here we can see libmsfui console command dispatcher core, and there's also this post. So Meterpreter is the thing obviously we're mucking with. We have a load command in Meterpreter, and so that is actually part of this librex post Meterpreter UI console command dispatcher core. So the reason why I want to open this up is so that we can have a look at briefly how these things actually work. So what are we looking for? We are looking for command oops, can't type, dispatcher core.rb, so that'll be that one there. Alright, so here we can see these are the base commands. These commands here are part of absolutely every Meterpreter session that you can establish, with a few caveats. But these are the default ones. Before you load any extensions, before you do anything crazy like that, these are the ones that you should get out of the box. So what I want to do is go down to command load, and you'll see here, this is the body of the function that we use to load extensions. And we'll just do a quick run through, right? Quite simply, all it's doing is it's looking for this particular part here is saying if you specify -L, we're going to go and have a look for whatever DLLs are currently sitting in the gem folder, or in the local development folder, and we're just going to do like an autocomplete tab style list. Okay, so we're not too fussed about the load ops here. But what we are interested in is going through and making sure that, first of all, we haven't already loaded the extension. And if we haven't, we then use this command here where it says client.core.use md. Now md, as you can see, is the name of the extension, right? So that's all it does, is it calls this client.core.use and passes in the name of the file. Now from there, a bunch of other magic kind of happens, and it's quite involved. But in short, what it does is it locates a file on disk based on the current session type. So for example, 64-bit Meterpreter, native, and it will find the name based on ext_server_, just like what you can see here, followed by the name of the extension, so Incognito or Mimikatz, and then after that, it'll add a suffix which is specific to the platform and the architecture. So in this case, it'll be .x64.dll. Okay, so With that in mind, it then goes off and tries to do a bunch of other magic. So this will be, we're going to have a look at that now. We'll find this in librex post interpreter. Is it client core? I think it's client core. Command dispatcher. There it is. I think def use. Here we go. This is the function that we were looking for just here. Okay. So as I said, first of all, so this is a recent addition of mine. See how it's calling get loaded extension commands. So get loaded extension commands is something where Metasploit communicates with an interpreter and says, hey, I've got this extension that I'm looking to load. Can you tell me if you have any functions associated with this extension loaded already? And if it comes back and says no, it'll basically mean, it'll give you a list of commands that is blank. It'll say, no, I have no commands associated with this extension. So you can see, unless the commands are already specified, we're going to go ahead, excuse me, and we're going to load it. Regardless, what we're going to do is we're going to call this add extension function on the client. Now what this does is on the MSF side is that it takes all of the extension specific functionality in Ruby that adds all the new commands to your help and to your session and wires those in. Now the reason why this is important to be done even if this section here isn't done is because when we get sessions reconnecting or whether we get stageless sessions coming in, we may already have a Meterpreter session that is currently running that has extensions in it already. So we don't want to have to say, hey, go and load incognito again, and here's a big fat binary with the contents of incognito in it already, when it's there. Okay, so this is us saying, if we don't have those commands, then let's load it. But if we do, I'm going to assume that you've already loaded that binary, and we'll just wire in the local stuff based on that. Okay. So once it's figured out exactly where to load things from disk, which is what you can see here, it then calls load library, right? And load library is a mess. Quite frankly, it is a mess. But the important things to note here is that what we're doing is we're specifying a couple of really important bits. So this one here in particular is we're marking this as a Meterpreter extension, and that will actually cause it to be reflectively loaded inside Meterpreter. So from a process point of view, that's pretty much all you're interested in seeing. We can go a little bit deeper, but effectively it loads it from disk, adds some metadata and sends it down the wire, and from here it starts to get a little more fun. So let's just see what's going on in chat. Hey Menstrual. Okay, which fuzzy file finder do I use in Vim? I'm using Command T, I think. Yeah, I'm pretty sure. Pretty sure it's Command T. I'll find out. I'll validate that when I look at my config a little bit later on. Mongo bug. I'm a Metasploit noob and haven't installed a new version in a while, but is there a way to make it take less than 5 minutes to launch a console? Yes, Mongo bug. It is actually very quick. The reason why it took as long as it did here is because of the resource stuff. But if you have a look at this, I just type MSF console now. 2, 3, there you go. In just under 4 seconds, you've got a console. So it shouldn't take anywhere near as long as it used to. There you go. Alana's had exactly the same story as well. So updated clean install might do well. Yep. Get latest, work from head, and you'll be fine. All right. So back to this time, we're going to go back to Windows land, and we're going to start navigating the code. So with the Meterpreter session up and running, we've actually got a thread sitting in the background receiving commands from Metasploit. Okay, and you'll find that, at least remember, this is predominantly Windows specific. We can get into all kinds of other bits and pieces later on. But what you can see here is that this function, this init function, is actually invoked from outside of Meterpreter. So it could be a stager, for example. So this is invoked by the stager, and we then basically pass off a bunch of metadata over to a setup function called server setup. So server setup is quite hefty, and there's a lot of debug stuff in here which you can for now ignore. But what it does in essence is it creates a new thread for the server to run on, allocates some other, for now, non-interesting stuff that it uses for accounting, keeps track of some session related information, and then it goes and creates a set of transports. Now, transports are a beast that I could probably cover in a completely separate stream, because there's quite a bit of information just in the way that transports are handled. But what I'd like to say at this point is all this is doing is that it's parsing a configuration block and creating a list of available transports that this Meterpreter session can use to talk back to Metasploit. Okay, so we can ignore all this stuff for now, and we can move on. This is again all just, it's setting up some function pointers and nothing particularly special. Here you can see we're loading stageless extensions. So as I said, when you have a stageless payload, you definitely have MetServe baked in. You may also have standard API and priv and a bunch of other extensions, and so that function there actually iterates through the rest of the configuration that appears after the config block and reflectively loads all of the extensions that were loaded during, that are wired in as part of the stageless payload. We then kick off a scheduler, which does a bunch of magic behind the scenes in a separate thread. It keeps track of things like channels and asynchronous communications, that kind of stuff. So when you, for example, type shell, you actually get an interactive shell in your Meterpreter console. There's actually a scheduled job running that keeps that data going behind the scenes while Meterpreter continues to function as per normal. Okay. Then we initialize our current transport, and then we kick off what is effectively a dispatch routine for the transport. So the transport's sitting there behind the scenes, and depending on the transport that's invoked, it does something particular. So for example, for TCP, which is an active permanent socket, it just sits there and polls the socket. And it uses select and a bunch of other socket related routines to try and be optimal, for want of a better expression. And that allows, things to function outside of the dispatch routine without chewing up too much processing power. In the case of HTTPS, for example, that routine will periodically poll out to MSF with a get, and when it gets a command to run, it will post the response back to Metasploit. Okay, so that's effectively all that does. And what we're doing here is we're saying, if the result of dispatching wasn't that great, i.e. maybe a transport died, then what we want to do is flick over to the next transport in the list and try and reconnect on that. So this is where the guts of the sort of transport failover stuff actually works. Okay. Anyway, so that's kind of the crux of the routine. When all the transports fail or when the user exits, we terminate all our transports, get rid of all these dispatch routines, destroy the scheduler, join any thread that happens to be running, like forcibly shut those down, clean up after ourselves, and then we're done. We return control to the caller and off we go. Okay, so that's all kind of high level stuff, but it's important sort of foundational knowledge to have while we're navigating. Okay, while we're actually running and we've finished sort of initializing and all that kind of stuff, and then we start loading extensions, this is where it starts to get important. So what I'm going to do is I'm going to dive into I think it's remote dispatch. Let me just find the function that I'm talking about. Here we go. So we've got this load extension function, and the load extension is called, as you can see, during load stageless extensions, and it's also called as from remote dispatch here. Now this is the bit that we're actually interested in, because we're going to assume that everything else has happened beautifully up until now. Okay, so we've got this thing called request core load lib. okay? And you'll see here, based on this search, that request core load lib is specified in Meterpreter's metadata for MetServe itself. That is the core function, the core piece of Meterpreter, as this is identified by this command core load lib. So when Metasploit says, hey, I want you to load an extension for me, it actually uses this string core load lib and says, here's the command I'm executing, and here's all the metadata that goes with that command. And so Meterpreter, when it receives that packet, it looks at this string and says, hey, which thing is it that you're looking to invoke? Oh, that's associated with request core load lib. So we're just going to take the packet and pass it into this function. Okay, and so when we type use incognito, Metasploit wraps up a bunch of stuff into a big fat packet, sends it to Meterpreter, and Meterpreter will call this function here. This is where the magic comes in. Okay? Any questions so far? Are we lost? Hey, what's this project all about? I think Justin. Yep, there you go. Justin's already answered that. Yeah, so we're working on extending Metasploit's rat effectively, clone style. That's what we're looking to do. I understood half of those words. No idea what Metasploit is. Yep. Okay, cool. Chat's all good. No questions from what I can tell. No pings for me on top of what I already have. Got milk. I'll have a look maybe tomorrow at that Metasploit payloads thing for you. Okay, let's have a quick rundown. What is the shortcut? Whoa, no, is it? There it is. Okay, magic shortcut to full screen stuff so that we can see more code. Right, so here's the fundamentals of what loading an extension actually looks like. First of all, there are some API style functions that come with MetServe that allow you to pull packets apart. Okay, so this is one example of it here. You can see packet get TLV value string, and what we're doing is we're saying, can you please take this packet, which is in this variable here, ppacket, take that packet and extract any value that is associated by this ID and return it to me as a string. Okay, so if you look at the function signature here, I don't know whether you can see that, it might be a little bit too small, but it returns a pointer to a character, which is effectively like a list of signed bytes, but that's not too important. And you give it a packet and a TLV type. So TLV stands for type, length, and value, and this is effectively what the core packets of Metasploit's communication with Meterpreter are actually made up of. So when you send data, you say, this is its type, this is how big the data is, and here is the value associated with this data. Now, it is called a TLV. Technically, it's LTV. We send the length first, followed by the type, and then the data that's associated with it. And then as you're building packets up, you can have any number of these, and then there's like a header that wraps up all of them. So that you can quite easily pull it apart at both ends. And so all of the Meterpreter types have an implementation of this TLV style library, and that includes a custom version in PowerShell for the PowerShell extension. The Python version that Spencer wrote has that. The Java version, I can't remember who did the original one for that, but I know Tim works on that quite a bit these days. So yeah, it's not too involved, but it takes a bit to make sure that you've got it right. So here we're pulling out the library path. This isn't too important. This is really only an issue for when you're dropping things to disk. And flags comes with a bunch of other metadata as well. So for example, we're actually not going to be looking at this one for now. We're going to be coming down to here. So if we are loading it as an extension, like I said, this is an important thing. If we're loading a library as an extension, then we're not putting it on disk first. That's really important. That's obviously for forensics reasons. So if we have the library, and the library is effectively a reference to the thing that we're looking to load, and it's an extension, then we're going to call load extension. Okay? And we're giving it the library, we're giving it an indication of whether to load things reflectively, which, as you can see, it actually does do, based on, where is it? false. This is set to true here. So what we're doing, there's a bit of metadata that's passed in that says whether or not you should be loading reflectively. And by the looks of it, this might even be ignored when it comes to the load extension function. So this could be a little bit of code tidy that we can do at the same time. So let's have a look at the load extension function. Okay. We're really starting to get into the guts of it now. So what we do, because we need to keep track of some of the extensions that we're loading, we actually have an extension type. As you can see, it keeps a reference to the library. It's got some pointers to a few functions, and it's got pointers to a list of commands that are associated with the extensions. So start and end are just basically pointers to the start and end of a command list. And finally, it's got a name, and we use that for sort of keeping track of which extensions have been loaded. Okay, so we allocate one of those and we make sure that we can, and then we set it to 0. I mean, what we could do is change this to calloc, and we could initialize it to 0 in a single step, but that's ultimately not too much of a problem. Now this is interesting, right? So we've got this this library that's been handed to us, and this is a reference to a module. This module has already been loaded. So actually, let me just quickly take a step back, because where are we? I'm all over the place again. Let me just open this up from here again. Close that off. Right, so just back up here, we can see the library reference is loaded where? Here. Here it is. This is a little bit of magic too. So what we're saying is, if we don't load the library from disk, right, then we're going to attempt to load this reflectively. So this data_tld.buffer and data_tld_header.length says, here is the buffer that contains the DLL that we're looking to load, and here's how big it is. Go ahead and load it reflectively. So reflective DLL injection is, again, probably another topic that I could spend quite a long time talking about. But to sum it up, it was a method of loading a DLL directly out of memory that was created by a guy called Stephen Fewer, who runs a consultancy called Harmony Security over in Ireland. He is a very smart dude. He also has recently built an app called Relize, which is a reverse engineering tool. Super smart guy. So what reflective DLL injection does is it bundles up a special function inside every DLL that supports reflective injection. And it says, okay, we're going to put that thing in memory, and we're going to find the function that can load itself, and we're going to call it. Excuse me. What that function does is that it implements a very custom PE loader. Excuse me, I've drunk too much tea already. It implements a custom PE loader, and that PE loader functions almost exactly the same as what the Win32 native load library function does. So it maps sections to memory, it handles relocations, it fills in the import address table, and just basically makes sure that the PE, the DLL itself, is put in memory and has everything wired in as it would need. It's pretty clever stuff. And the one thing that it doesn't do is that it doesn't register the DLL with the host process. So if you're looking at it with something like sysinternals tools, you won't actually see that the DLL has been loaded. So this is one of those things that makes it a little difficult for people to find when they're doing forensics and they're looking for stuff. So yeah, that's basically what that's doing. If you guys are interested in a deep dive into how reflective injection works, I'm happy to do another stream on that, but we're not going to cover that at this particular point. The only thing that's important for you guys to know is that we've got a DLL currently sitting in memory, and we need to have it reflectively loaded, right? That's pretty much what it boils down to. That loading happens from memory and maps itself into another area of memory, which is done on the fly without being written to disk. And it's that area of memory where that extension currently lives that when we tear down Meterpreter doesn't get freed and doesn't get cleaned. So that's what we're trying to fix. Okay, so this library that's returned by this load library R function, which is part of the reflective DLL source, we'll get to that later, that returns a reference to a library that you could use with pretty much any other DLL or library-based Win32 functionality. Pretty much, there are some exceptions. And that's what gets passed into load extension. Okay, so load extension says, if once we've created this little extension metadata thing, we're going to keep track of the handle to the library, and then we're going to see if we loaded things reflectively, because in order to resolve functions from a reflective DLL, you have to do things slightly differently. So here we're saying if we loaded this DLL reflectively, then we're going to use getProcAddress R, which again is a function written by Stephen Fewer to do figuring out of a procedure's address inside a reflective DLL. And so what we're doing here is we're looking for some function pointers. We want to be able to initialize the extension, deinitialize the extension, get a name, let it know when a command has been added. That's kind of irrelevant for the sake of this discussion. And also look for a function called stageless init, which means if during the initialization of a stageless payload, the extension was loaded, we're actually going to call stageless init before Meterpreter even kicks off and starts talking to Metasploit. And that's the thing that allows you to do a bunch of custom commands before your payload even starts communicating back to the attacker. So that's actually pretty cool. If it's not loaded reflectively, we just use the classic proc address. But in the case of extensions that come with Meterpreter on Windows, they're all reflectively loaded. So this code path here tends not to be used in Windows. Okay. Then we go through and we say, right, does it have an init routine? If it does, then go and initialize it. From there, we're just going to add a bunch of supported commands. So we can say, hey, I want you to give me a list of commands so that we can wire it in, and we're going to keep track of which commands have been loaded by the extension that we're just loading, and we're going to tell other extensions about those things as well. Now, that seems a little bit obtuse, but it's actually important. So in the case of things like the Python extension and the PowerShell extension, both of which have bindings back into Meterpreter. So that is, you can do get system from PowerShell, and you can do things like getting the current user identity from Python. What they both do is actually construct TLV packets and pass that back into Meterpreter and say, execute this for me and give me the result, and off it goes. So it's kind of driving Meterpreter in the same way that Metasploit does. But the difference here is that for those extensions to be able to function and provide those bindings, they need to know that the required functionality has been loaded already into Meterpreter. So for example, there are Kiwi bindings in the PowerShell extension. So you could dump credentials from memory using Mimikatz, but in order to do that, the Kiwi extension needs to have already been loaded. So it's keeping track of which things have been loaded, and it can say, hey, you haven't loaded the Kiwi extension yet, therefore here's my error saying go load the Kiwi extension, otherwise I can't execute that command for you. Okay. So that's exactly what this is doing here. So it's basically saying, go through for each extension and tell them of all the commands that we've actually just added. Okay. Right. Sorry, that's what that one does there. And then this one is actually saying, by the way, the extension we've just loaded, here are all the ones that we've already loaded before you even got here. So we've got the two-stage. The new one needs to be told of what's already there, and all the ones that are already there need to be told of the commands that the new one's providing. Okay. and then it keeps track of them in this extension list, and off we goes. And that's it. That's it. But the result of this parsing, as you can see here, is, see this packet add TLV string response type method. Okay, so what this is doing is that this is saying when we've loaded this extension up, we are returning a list of all the methods that the extension now supports. So when we go back over here and we look at this list of commands, you can see here commands equals load library. So this list of commands is what comes out at the other end. Okay, and from there we can say, right, this extension has all these commands and it does all the client-side wiring up, and you get your help and your autocomplete and all that other lovely stuff. Okay, so there you go. That's a very, very high-level overview of how those bits and pieces kind of fit together, and hopefully that's enough to get you going with me at least. Questions? Has anyone got questions? Let's see. Use Meterpreter as by general and it says, oh, okay, cool. Well, sing out, is it Naxor? If you have any questions, I'm more than happy to answer them. It can be quite a confusing beast. Mongo, interesting stuff. Similar stuff to what some P... Yeah, exactly. Similar stuff to what some PE packers do. I guess you're referring to the reflective DLL stuff. They sort of bake in their own custom PE loaders and various other bits and pieces. Yeah, Justin, I know you always love Get System. And bugger you, I didn't ruin it. So, although by the looks of it, Mongo does have a semi-serious question here, so I will answer that. Isn't Get System kind of cheat mode? Well, no. Back in the day, it used to have exploits baked in. Get System is no longer an exploit. It will never be an exploit again. Get System is literally a mechanism for extracting a system token and applying it to your current session. That's all it does. It doesn't perform exploitation anymore. So Get System isn't really a cheat mode. It's just more of a way of saying, give me a system token when I already have permission to do so. Back in Windows XP days, pretty much everyone had permission to do that, right? So that's why it felt like cheating. But these days, that is not the case. So with Windows 7, even Vista onwards, you weren't able to do that. So you need to have elevated privileges in order to be able to grab yourself a system token so that you can do other more interesting things. Why did they change it? Alana, I was responsible for changing this. The reason why it was changed is because the original version of the exploit that was put into Get System was something called the, is it KI Trap 0D exploit that Tavis Ormandy came up with as a brilliant exploit. Yeah, thanks Gottmilk for referencing that. That was causing various machines to blue screen. And the reason that it was causing things to blue screen is because when people type Get System, they don't actually realize that there are a bunch of methods that it attempts behind the scenes. So there were 4, there's now 3. The 4th one was that Tavis Ormandy exploit. Okay. Now that's been removed, boxes don't blue screen, but that exploit is now currently it's a post module that allow you to do a local sort of exploitation thing. So the exploit's still in Metasploit, but it's not baked into Get System. And I can just imagine that whoever it is as part of the usual crew that teases me about this stuff is loving the fact that I'm talking about this now. But that's effectively what's going on. Get System gets a system token. It tries 3 different ways to do it, unless you specify which one you want to use. And it's no longer an exploit. Okay? Righto. Let's move on. We're going to start doing some dev. That's what we're going to start doing. So to begin with, we're going to start at the top and we're going to say this is the command that we want people to be executing. So that means we're going to have to go to the command list for, where is it? Is it up here? We want to wire in those commands. Here we go. Custom commands. So we have a core load lib function. What I want to do is I want to provide a core unload lib. Okay, that's what I want to do. I want to create an unload lib function. Now, because of the nature of these things, I'm pretty sure that I can't unload this in POSIX Meterpreter. I mean, we'd really only have 1 or 2 extensions anyway, so I'm not going to focus on POSIX. So I'm only going to put this in the Windows section. So you can see here inside this if-def win32, I'm only exposing this request core unload lib function as part of the win32 source code. Okay. Now, where is this defined? It's defined in a header file, isn't it? Right, let's just go back to what we were looking at before. And let's go find out the header file that it's declared in. There we go. So I'm going to have to do the same thing here, right? So if def win32, I didn't need to do that. Load, oops. Unload lib. Okay, so we're going to create this function now. And as I sort of find my feet, hopefully you guys will see what it is that I'm trying to do. I bet you, I know people are still talking about get system. Okay, so let's go and define what this function looks like. Okay, so that'll be in remote dispatch. I'm going to put it just here. All right. Now, regardless of what we do, I tend to return error success here because the return value of this is actually telling the dispatcher how to behave. And whether this succeeds or not, I still want the dispatcher to carry on doing its thing. So I tend to return error success here. But anyway, what we want to do is we actually want to load, we want to get access to the name of the extension that they're looking to remove. Okay, so we're going to need to start talking to the packet, and we're going to have to formulate a response. Okay, now let's make this a bit bigger again. Righto, so here we go. This is where I'm in the same position as you, and I have no idea how this is going to unfold. I'm just going to wander aimlessly, and hopefully you guys will join the ride. To begin with, we need a pointer to a character, and we'll call it extension to unload. And we're going to pull that out of the packet. So packet get TLV value string. We're going to pull that out of the packet. See how we're actually given that in here as part of our function prototype. And we're going to need a TLV type. So have we got one that we can actually use now? So there's as you can see, there are quite a few TLV types already. There's method, machine ID, migrate, stuff, request, result, temp, target path, user, UN. By the looks of it, the answer to that is no. So we may, let's just have a quick look to make sure that there isn't something that we could reuse here, because I don't necessarily want to define new ones without necessity. So method, request ID, exception, result. I guess what we could do is just have a type string. We could just say we're only taking one value here, or perhaps multiple values. Maybe people want the ability to unload more than one extension, but maybe we'll come back to that. So let's maybe just do that. We'll just pull out a string without any identity to it, and from there, if we feel that that's not good enough, then we'll come back and address it later on. Okay, so let's just go back and we'll go TLV type string. Okay, so we're assuming that when this command is invoked by MSF, they're going to pass in a string. They're going to give us a string. And because we're actually just starting to do development here, I'm not going to put in all the error checking until we get towards the end when we know things are going to work. Okay, let's have a quick look at chat. Yeah, thanks Justin. Rip get system. I hate you all. Get system, get system, get system, build a wall. Stop making that joke. Mongo's VS looks badass. Got to try moving that solution explorer tab to the right. Yeah, yeah. I think it's been. It would be like 12 years, if not more. Actually, let me think. 2001 was when I started. Oh no, 1999 was when I started using Visual Studio professionally, and it's changed a lot since then. Pretty glorious. Things you never even think to change to use. Yeah, that's so true. That's part of the reason we do this stuff, right? Okay, I think I've finished my work for the day. I hope you're still streaming when I get home. I'm pretty sure we will, Alana. We'll see you then. Righto. Okay, I'm going to start picking up the pace a little bit now, given that we're already an hour in. So here's my thought process, right? I need to be able to say, I've got an extension name. We need to go and find it in the list of extensions, okay? When we've got that list of extensions, we've got that value out of that list of extensions, we're going to remove that value from the list. Once it's removed from the list, we're going to call the D in it, and then we're going to ditch. Actually, no, we're not. We're going to remove the commands first, and then we'll call D in it. Right? Because that will give us the ability to make sure that no commands will attempt to be executed as part of some asynchronous process prior to actually having those things unwired. That's, I think, important. We could use locks and things like that as we go anyway. So, but what we want to do is we want to be able to say, let's have a think. What are we doing during load? We've got this load extension. Technically, we should probably just pass this whole mess off to the same location and make this fairly simple. So let's do this. Unload extension. Extension to unload. Because all the magic seems to happen behind the scenes there anyway. We may, as we're doing this, have to provide more information about what to do with the extension. We may even need to keep track of the flags that came with the extension loading so that later on we can say, hey, if we loaded this reflectively, then we need to behave slightly different. Excuse me. But yeah, hang on, we've got more questions. OJ, what's with this P packet? Does a packet bundle up multiple TLD things? Okay, so first of all, P packet is a naming convention that original Meterpreter developers used. It's kind of like Hungarian notation. So P packet means a pointer to a packet. So if I show you this again, you'll see that the packet is actually a pointer to a packet. So that's what that little P tends to mean. I hate that convention myself, but you know, when in Rome, you do as the Romans do. Does a packet bundle up multiple TLD things? Yes, it does. There can be multiple instances of the same TLD value. There can be groups of things. So for example, you might say, if I wanted to get a full list of extensions and their commands, you could say, right, let's create a TLV group. And here's the name of the extension, and here's a list of all the commands that come with that extension. And then we'll add that to a packet as a group. And then we'll do the same for the next group, and the next group, and the next group. So you have multiple groups, and then inside those groups, you can have multiple instances of the same TLV. And it's up to MSF to bundle things into discrete packets. Yes, exactly. And clearly it has to be in sync with what Meterpreter is seeing and expecting, and vice versa. But you have the ability to iterate through those things for each packet, for each group, etc. So, and you'll see that as we go when we get back to sort of tidying this up, and we decide to support the ability to unload multiple extensions. We can say, hey, you know, we'll just loop through all of the instances of the extension names that you've given us, and from there we'll unload them. So we literally just turn it into a loop. Okay. Righto, so we've got this unload extension. I'm just going to do exactly the same as where this is. Unload, oops, extension. And so this is just going to be a char pointer, and it is the extension name. So by default, we'll just return error success. what I need to do is take this and put it in remote dispatch.h, I think. Man, maybe not. Let's just check. Yeah, it is remote dispatch.h. So there's load extension, which means we can probably do away with this core unload lib. No, I'll leave it there for now, and we can tidy this up as well later on. But request core unload lib needs unload extension, and request core load. Okay, so that's exactly where they both belong. That's fine. All right, so now we have the ability to call that, and if we build this, it should technically build because we haven't actually done anything tricky at all yet. There you go. So it's gone through the remote dispatch stuff and it hasn't thrown any errors. So, but that's not surprising given we're not really doing anything. Okay, let's get back to our unload extension. So what we need to be able to do, as per our load extension, you can see that once we've created one of these extension instances, we add it to a list push G extension list. So this is a global list of extensions. So what we want to be able to do, I would assume, is find an extension. So is there a list find? There's a bunch of list functions. List add, list clear, list count, create, list destroy. But there's no list enumerate, list get, list remove. Here we go. So what does list get do? Let's have a look at that. All right, so it gives us the ability to, it gives us the ability to find something based on an index, but that's not exactly helpful either. So count, create, delete, destroy. What does delete do? That allows us to delete a particular entity based on index, which isn't that handy either because we don't currently have an index. Let's create, count, clear, add. Okay, so what we're going to have to end up doing then is we've got push, pop, shift. Yep, there's nothing there that looks too great. List remove. Ooh, that looks interesting. What does list remove do? Remove a given data item from the list. So it's probably doing, here you go, an actual comparison of pointer values. So that's not useful to us either because we don't actually have the extension that we're looking for. So what we're going to have to do is we're going to have to enumerate the list. We're going to have to iterate over the list, and we're going to say we want to be able to do, like, figure out something based on the identity of an element. So if we say list enumerate, what we've got to give it, we've got to give it the extension list, as you can see by that prototype. What was it called? It was called G extension list, global extension list. Hate globals. Okay. You've got to give it a callback function, and you've got to give it some state. Okay. So what we'll do is, if we have a look at list enumerate's declaration, we can see it's expecting something of this type. All right. So that means we need to have a function that looks like this. So let's call it find extension by name. Oops, should keep my things consistent. Okay. And by the looks of it, I would assume that this list enumerate function has the ability to bail out early. So list enumerate, let's call back while. Oh no, it's just keeping track of a running result. So we're not really worried about that. Let's say we want to go find extension by name, and we can give it some state. So what we're interested in doing here is we need a pointer to that extension. I'm just going to call it extension, and to begin with, I'm going to set it to null. Okay. So what I want to do now is I want to pass in a reference to that, and I want to be able to say when you find the extension, make sure that you tell us what the pointer is to that extension. So we need the extension, but we need to be able to pass in a value to search for and give them the ability to return something out. So that means we're going to need a structure. So what we'll do is we'll go type def struct extension finder, and we can rename this later. Finder. Okay, so it's going to have a pointer to a char, which is the name. We'll just call it name, and it's going to have a p extension, and that's going to come out with the extension. All right, so that means we don't need this anymore. What we need is an extension finder. Okay, and the finder, at the moment, we're just going to have the extension set to nothing. So what we'll do is we'll initialize that to 0, because that's what you should do all the time. Don't ever not initialize your variables. And so finder dot name is going to be the extension name that we were given. Okay, and then the state that we're going to pass in is the address of finder. So that's a pointer to the current finder state. Okay. What we can actually do is, yeah, that's exactly what we can do. So then by the time we've enumerated this, the result should be that if the finder pointer, if the pointer inside this finder object is valid, then we know we've found the extension. Okay. So we know p extension, we'll call it current extension equals welcome to C, by the way. So we're going to cast the data that we got out of the list to an extension, and then we know our let's go pointer p extension finder. So we can say p extension finder. We may even change the case of this. That's probably what we should be doing. Hey, there we go. Yeah, that's better. Keep it in line with naming conventions. We make sure that our structures are defined with all uppercase. So our finder equals p extension finder p state. Okay, so now we've got a reference to the finder state blob that we got from unload, and we've got a pointer to the current item that is being iterated over inside the list. So really all we want to do is we want to say if finder name is the same, so we're going to need a strcmp of some kind. If that's the same as the current extension's name, then bingo. All right. Now I'm pretty sure that the string compare function these days complains, right? So let's just strcmp. That's case insensitive. Yeah, I don't think that's a problem. So if that comes out as 0, so if the extension names are the same, then we have found the extension we're looking for. All right, so from here, what we want to do is we want to say the finder extension is the current extension. So we found it. We're iterating over the list. We found the one with the same name. We're just going to take that pointer and wire it into the state. And we'll just return true. So this means that when this list enumerate finishes, the result of finder of the actual enumeration should be that the finder contains a valid pointer to the extension that we want to unload, right? So let's add some debug output. So to begin with, what we're going to do is we're going to say, so there's a function called dprintf, which is baked into Meterpreter source code. I'm going to put a little tag in called unload, attempting to unload %s, which is extension name. Okay, so that'll give us some debug output that we can look at. We're then going to enumerate, and then from here we're going to say the result of, there we go, enumeration result, and we'll call that P. And we're just going to go finder dot extension. Okay, and then we're just going to return error success. So at this point, we're not actually doing anything particularly special. But what we are doing is we're looking to see whether or not our list searching capability actually works. Let's have a look what we got. Someone doot me? Yes, they did. That one guy nobody knows, zeros. What are you building? We are currently building a new feature into Meterpreter, which is, in case you don't know, is a little bit of a remote control utility that's used by security professionals during penetration testing assessments. Menstrual, I'm not sure if anyone's asked this before, multitasking, but have you found a way to get Meterpreter on a Win 10 machine without the stupid built-in AV constantly chucking a fit? Yes. Yes, I have. We can talk about that another time. That will not make it onto this stream. Okay, so I'm going to build this, and then what we're going to do is we're going to wire something in on the Metasploit side that will allow us to test to make sure that this stuff is working. So I'm going to hit build, and hopefully, oh, there you go. I did kill something. What did I do? The extension. I put an extra pointer reference in there, which caused it to be unhappy. Yep, I am uploading a rat, updating a rat. All right, so that's looking like it's working. Let's go back over to Metasploit land. Now, as I mentioned, there are a bunch of make commands that come inside the Metasploit payload folder, one of which is called make install C Windows. And that will take any pre-built binaries and drop them in the appropriate location. So if we have a look inside the Metasploit folder, and we look in the Meterpreter folder, you'll see that there's only 2 binaries in here and nothing else. Okay. Once that's finished, you'll see, there you go, we've finished building. Go back over here, call make install C Windows, and boom, there you go. So all of these DLLs are the ones that I've just built. We're particularly interested in the 64-bit ones. The x86 ones were clearly overhanging from previous builds, but we're not going to be using x86 until we know we've got the core of our functionality working correctly. So what happens now is that when there are DLLs sitting in the data Meterpreter folder, Metasploit itself will actually pick those binaries up instead of using the ones that come with the gems that are associated with the project. Okay. So yeah, basically that's the go. Now we have all the DLLs sitting here. We're going to need to spin up our console again. Let's just let that run for a minute as that runs. Actually, before we do that, I'm just going to cancel out of that. We need to add an unload function, don't we? So def unload, we're just going to go mod. So that's the name of the module we're looking to unload. And what I'm going to do is, given that we're actually, as you can see, we're part of client core here, we're not actually at the UI level. You can't do error messages nicely, and that's actually supposed to be one step higher. So all I'm going to do here is we're going to do some really, really basic stuff. We're going to create a new packet, and here, because I'm lazy, I'm going to copy and paste this. So I can never remember the exact syntax anyway. All right, so what we're going to do is we're creating a request, and that request is going to be a new packet. So this is a classic TLD packet. And the command that we want to bake into this request is the core unload lib. Remember, that's what's matching on the Meterpreter side. Then we want to go request.add_TLV, and we know this is a TLV type string because that's what we've decided to use, and we're just going to give it the mod. Simple as that. Okay. And then all I'm going to do, rather than deal with anything tricky for now, what we're going to do is we're just going to send it. Okay. So you can usually do this: response equals self.client.send request. I think it's pretty much just that. Send packet, wait response, send request. There you go. Send request, and you get a response. And that comes with all of the default timeouts and all of that kind of stuff on there. So, yeah. Anyways, that's the go. And then what I'll do at the end of this, because I like to see what's going on, I'm going to go standard error.puts response.inspect, because that will cough up the guts of the TLV and dump them into the console. Okay. And that's all I'm going to do. Now let's fire off MSF console. While that's spinning up, let's go back to Windows. And I'm going to minimize this, and I'm going to run debug view as admin. So debug view is the thing. So every time we do a debug output, a debug print, debug view is where it goes. So you'll have to have this running all the time to see exactly what's going on. Okay. And there we go. We got our handlers running. You can see them all sitting there. Let's spin up this one. I don't know what happened to this window, but geez, it's messy, isn't it? My Vim has died. There it is. Okay, so as you can see here, we've got this sending stage message. One of the messages that came out here is warning local file blah is being used. Okay? That is a warning that says it's actually loading content from that data interpreter folder, and it's there to say, hey, you've been doing some dev, you've got custom binaries, they might not necessarily be what you're looking for, so just letting you know. Unfortunately, one of the lines here has been gobbled by that problem I was talking about before, but the first thing you usually see is ext, so you just see metserve.dll, metserve.x64.dll, which is the first stage, and then after that we get standard API being loaded, followed by priv. Okay, so they're the two extensions that are already loaded in Meterpreter for you. Okay. Right, so we've got a session, as we can see. Let's just go and talk to that session, and we don't actually have a command in our help that says unload, right? So if we look here, we've got use deprecated alias for load, and there's load. Okay, but we don't have unload because we didn't wire it in. So what you need to do is you need to drop into IRB, and you can go client.core. And this core refers to this thing here, so we can actually call unload on this. Before we do, let's go back to Meterpreter, and you'll see here's all the output that I was talking about. So you can see there's a bunch of stuff. All of this stuff is Meterpreter spitting out its initialization routines. So for example, this is where it's spinning up, right? Getting ready to init with a particular configuration. Let's just turn the capture off just for a minute. It's saying, right, there's a pointer to the configuration block we were given, comms FD, so that's actually the socket descriptor. I know this might be a little bit small on your screen. I don't know whether we can change the, oh yeah, we can change the font. Let's make that a bit bigger. There we go. Hopefully you guys can see that. So there you go, that's a socket descriptor that the stager actually passed off to MetServe so that we could continue using the same socket. Bunch of other lovely random bits and pieces, initialization of core functionality, but here you go, check this out. Registering a new command, core unload lib. So that came from dispatch common. So that's it there, core unload lib. So it knows that core unload lib is a function that should be invoked when that particular string is passed in. So what I'm going to do is I'm going to clear that up, kick that off again. Let's go unload, and we'll just say unload priv. Now, anything bad could happen at this point, but the important thing is when we come back in here, check this out. Attempting to unload priv, enumeration result. There we go. We actually have a valid pointer, a pointer to something. So that means we've actually gone through, this has been executed, we've enumerated our list, and the result that got set here was actually came out as part of this finder.extension. So we've actually found that extension object that we're looking to free up, right? Which is great. Now, if we look at the priv extension, we'll focus on the priv extension for now. You'll see that it's got a dinit server extension, which basically calls command deregister all. And so what that does is it says, let's remove all of the commands that we had wired in before. And so we need to validate that if that happens, that it actually informs all of the existing extensions that it's being torn down and that those commands are no longer available. Okay. What's going on here? Whoa. Whoa. Bit of stuff going on. So you're updating a rat. Yep. Shocker. OJ, I'm excited for DC Sync. Useful in red team assessments. Yeah, me too, man. I'm really hoping that I'm going to have that Kiwi update done by the end of the week. So fingers crossed. C is literally never used for anything other than cybersecurity these days. Yeah, sure thing. Sure thing. Yeah, as Justin says, it is actually used for plenty of stuff. Lots of embedded stuff, exactly. Also, most of your utils are still C, so is the kernel. Me gets the feeling someone's trolling. Okay. Craziness, you want to get your own house. Nothing going on there. You guys are talking crap. Dozens of dollars spent buying proprietary software. Burp, IDA, Windows. What else we got going on? Yeah, whatever. We are busy arguing. Okay, I'll leave that to you then. I'm wondering if pointers to config blocks are useful for forensics. They are no more or less useful for forensics than any other pointer associated with this. So yes, I would say if it is, then almost absolutely everything else would be as well. Is it spewing debug messages by default? No, it doesn't. That is, you know how I talked to you about common.h? That's this debug trace. If you define this debug trace, then all of those dprintf calls will turn into an output debug string call that debug view is able to read. If you comment that out, which is what's done by default, then no debug output gets rendered whatsoever. Wondering if the pointer's coming by Sam. That's right, Mongo, exactly that. It is. It's running debug view, and dprintf is a wrapper around output debug string. That is spot on, exactly that. Wondering, would a victim need to be catching these debug messages, or can they get them post-compromise? Yeah, it's got to define, so you won't see that unless you've deliberately compiled that stuff into the binaries. Okay, so what I'm going to do now is I'm going to, once I found that extension, I'm actually going to remove it from the list. Now, in order to remove it from the list, some magic list locking is going to have to happen. So what we're going to do is we're going to say if the finder.extension came out as non-null, let's put another message in here saying found extension unloading. Okay, just to let them know that we've got a bit of progress. So finder.extension, we know that's a pointer to an extension, so we can actually do Where are we? dinit. We can call dinit on that extension, but we actually need to, there you go, we need to pass in a remote. We don't actually have one of those, so let's adjust this. A remote is like, think of it as like a massive blob of world-related information that describes the current state of Meterpreter. It's an interesting name, one that I don't necessarily like. So we've got to put that in remote dispatch. And then remote dispatch common when we call unload lib, which is in remote dispatch.c, we actually need to pass p remote into the function. Okay, so now we've got access to a remote in our remote dispatch common. We should be able to, where are we? Go to the definition of that. So now we can call dinit and pass in remote. So dinit will hopefully, we'll call this, and you can see deregister all. Now what does deregister all do? Let's have a quick look at that. Whoops, need to change that to entire solution. Base, here it is. So it iterates through the commands that it's been given and calls deregister on each command. What does deregister do? Searches the extension list for the command, which isn't surprising. And then if it finds it, it frees it up. Okay, so that's literally pulling out just the commands associated with the extension. So that's interesting. My feeling is that when we deregister and we pull those commands out, we may actually have lost them. We may actually have to do something more, or perhaps even on deregister, iterate through any existing extensions and say, hey, you know, we are removing these commands. Excuse me. Let's just kick that off for a minute. You may well have noticed that back over here in Metasploit land, we got this operation timed out. Now the reason why the operation turned out is because we didn't actually return a response from our handler. So in order to sort that out, while that's doing its building thing, let's go back in here and we're going to create a new packet. We'll call it response. If I can type, we'll call it response. Packet create response, and you give it the packet that came in. We say, I want to create a response to this particular packet. And what that does is it wires in some metadata so that Metasploit knows that the response is associated with the command that went out. And then from here we want to go packet transmit response. We've got to give it the result that we want to give it. So for example, I'm just going to go error success. Actually, what we'll do is we'll go dword result, which is fairly typical. We'll pass that in as part of the response and just give it the 2 pointers that it needs. So it needs a pointer to the remote to transmit the response because the remote keeps track of the current transport, and it passes the packet down into the transport mechanism so that's returned to Metasploit. And this is the response that we want to send. Okay. So hopefully that should build cleanly. Hooray. So now when we do that exact same thing inside a new session, we shouldn't actually have any problems. It shouldn't time out, it should just work. Okay. Now I don't need to reload Meterpreter at this point, but I do need to reinstall the binaries. I'm going to exit out of that session and we're going to spin up another one. Yeah, you can see all the shutdown stuff that's going on here. Here we go. Finished. Exiting with this. So we can see that Meterpreter is actually shut down cleanly. Over she goes. Right, so we have a valid session again. Let's drop into IRB. So we remembered everything. There you go. Client core unload priv. Right, straight away you can see this has responded with something. I'm going to run it again. So the packet structure actually has an inspect overload that allows us to see the stuff that's come out. The ones that we're really interested in are this request ID matches the request that went out, and that's how it knows that it's got a response. It's got an integer value of 0, which represents the result of the call, and so that's error success. UUIDs come back with every single packet, which isn't particularly interesting at this point, but just is worth knowing. And the method that was called was core unload lib. So we can see we did actually get a response that time. Going back to debug view, you should be able to see, here we go, found extension unloading. Right, so we've technically unloaded an extension, like the commands shouldn't work. Let's go back here. We can see that priv commands are still in here, right? If we run get system, what do we get here? Operation failed, the request is not supported. Check that out. How interesting. So what that means is it was unable to find the command. Like, so if we did hash dump, there you go, request is not supported. So it has actually unwired the command from the remote. So that's good. What else has it got? Time stomp. Yeah, anyway, point is that we can see that the priv extension has been unloaded behind the scenes, and we're getting error messages saying, hey, we don't have access to that functionality anymore. So yeah, that's exciting. What do we got here? For now, I am going to ignore that one guy that nobody knows until he asks a question. Hey, Parks, thanks for coming along, buddy. Nice to see you. Lol unknown, general program question. If I'm making a chemistry game and I have compounds and the user must select 2+ to make a bond, would a binary tree be a good way to find all possible solutions, or is there a design pattern that would be better as opposed to having a class full of if checks? Chemistry game, I have compounds and the user must select 2+ to make a bond. I would not necessarily look to use a binary tree. There's probably better data structures like N-way trees or some other kind of tree that would probably work better for you, so maybe even finger trees, but I don't really understand the problem well enough to be able to give you an exact answer. So, yes. Anyway, what have we missed? Random but related question. Are Meterpreter sessions encrypted? The answer to that isn't direct. HTTPS sessions are encrypted because of the S in HTTPS. HTTP sessions are not encrypted. TCP sessions are encrypted once Meterpreter is running. So, like for example, the first stage gets sent down the wire in plain, but once Meterpreter takes over communication, it wraps it in SSL, and from there everything is encrypted. We're looking to move to, encrypt everything as much as possible. POSIX also has it. Metal also has it. Oh, actually, Metal might not have it yet. Python doesn't by default, neither does PHP. But again, they're all things that we're looking to fix. So the short answer is, for the most part, on Windows, if you're running a Meterpreter session on Windows, either with HTTPS or HTTP, then an established Meterpreter session is encrypted, yes. Okay. Kilu, hey guys, I'm new. What's he doing? Windows 10 remote exploit. Nah, mate, we're building some extensions into a post-exploitation tool. Okay. I hope that answered your question, Mongo. Righto, let's move on. Okay, so we know that we can unload extensions, but we actually don't know what kind of damage that's doing. Because as far as I'm aware, if we then, actually this will be interesting, right? Can comp had fun looking at HTTP? Yeah, exactly. HTTP. If you're going to debug sessions, make sure you use HTTP and fire up Wireshark. You'll see lots of stuff. What I'm going to do here is I'm going to use a new extension. We're going to use PowerShell. Okay, and what can I do? I can go PowerShell shell and get an interactive PowerShell console. And I should be able to do, what is it? Metasploit, Meterpreter, elevate. I think that's how you do it. Okay, it's not how you do it. I'm going to have to look at my own documentation for a second. So let's go back over here. GitHub.com Rapid7 Metasploit Framework. So there is something on the wiki about this somewhere, pretty sure. So let's go to the wiki. Meterpreter PowerShell extension. I haven't got detail there, but hooray, I linked to the original request, pull request. So here we go. There should be some stuff in here that's useful. Okay. I'm doing this bit wrong here. So I need to do, I had the syntax around the wrong way by the looks of it. Sorry. So that means E should be a reference to an object. Okay, so I should be able to go e.getSystem. Yeah, is that what it is? Does not contain a method called getSystem. Did I do it wrong? I probably did it wrong. Get SID, get UID is system. So that's U. What about E? It does have get system. Ah, I am still typing it wrong. So we want to go E get system. Aha! Okay, there we go. Interesting. So that's a way of actually, we're now interacting with the Meterpreter session from inside PowerShell that's baked into the Meterpreter session, which is a little bit confusing. But the important thing here to note is that like getSystem clearly is failing, but it's not actually returning an error to say, hey, we can't do getSystem anymore, because it doesn't know that the priv extension no longer exists. Okay, so this is where we now need to start doing some accounting inside Meterpreter, so that we can make sure that those commands actually get removed. Not having the opportunity, lack of external knowledge, probably answer the question. Would a reverse HTTPS session still be viewable if there was a network-based MITM? Parks, you basically need the SSL cert, right? You need to be able to, if you can man in the middle and decrypt the traffic, then yes. But you need the certs, basically. You need the keys. If you have those keys, then yes, absolutely. But given that the certs are generated on the fly, yeah, who knows? A lot of AV is clearly hooking S-channel and whatnot, so yes, it would be able to view the content as it's going across the wire, but that doesn't seem to matter. AV clearly doesn't give a shit about that for the most part, because I haven't really seen it get in the way. Okay, so let's get back to here. So we call unload extension. The extension here, we're actually pulling it out of the list. We're deinitializing it. So the question here would be, should we be removing, we should probably remove the extension from the list of extensions now, before we deregister those commands. And the reason for that is because we don't want it to be maintained as far as metadata is concerned anymore. So what I'm going to do is I'm going to say calling dinit, change that message there. Here what we're going to do is found the extension. We're going to remove from the extension list. Okay, so I'm going to remove that from the list. So we need to go list remove. What is it? G extensions list finder.extension. So that removes the extension from the list of extensions that we're actually currently tracking. We then deinitialize, and now we want to free the library up, right? And as part of our extension object, we have a reference to the library. Okay, so that's a handle to a library. We actually want to remove that. How do we unload? Well, that's an interesting question, because we've got this get proc address. We want to see if there is the ability to unload as well as load. It's not in that one. Load library R. What does load library R do? Oh, it's not part of this solution. Just a sec, I'm going to go find it. Sorry, yeah, I mistyped it. So we've got load library. Let's open that up. We've got load library R and we've got load remote library R. So it looks like we don't actually have the ability to unload the library, which is interesting. The question would be, is that important? Do we technically need to unload it, or are we able to literally just clean it right out of memory? Should we be able to just say, hey, this is the space that it took up, and let's go from there? We may have to do that and just see what happens. And then once that's actually done, we can just set the memory to 0 and free it up. But before we do that, it's important, again, we're going to have to go and dive into the detail of load library R. So you can see here is the core of the function says go and find the reflective loader inside whatever it is that we've been given, and run it. Okay, so as you can see here, we make sure that we mark that particular area of memory as read write execute, so that it can go and reflectively load itself. And then from there, what we do is we call the reflective loader, and then we call DLL main. So these are all fairly standard things. But the question is, when we return, what are we doing when we return? We return hresult. What is hresult? Hresult is, that is for payloads only. So we call DLL query module, and we pass in an address. So we're expecting hresult to actually come out, which is a handle to the module. Right, so let's see what that does. Let's go and have a look in one of our extensions, and we'll see, is that where it's being included? Yep. Righto, so we need to have a look at what's going on in the reflective loader. Brace yourselves. I've looked at this code a fair bit, and I'm not going to dive into it into a great deal of detail, because it is quite confusing. But the important thing to note is that when we call DLL main down here, LP reserved is a reference to the app instance. So that's what we're returning. Process attach hinst DLL. So that gets called from here. Where are we? Null. So that gets handled as null when we call DLL main with query module, and that comes out. But when we call DLL main for the first time, that's actually done in the reflective loader. So inside the reflective loader, I know I'm being a little bit vague here because this isn't the most intuitive code to read. But in the reflective loader, once we finish loading, the last thing we do prior to returning a reference to DLL main is calling it with UI base address, which just happens to be get the process loaded modules reference. First that, and here we go. UI base address. Okay, we can ignore all that. Here we go. Okay, so that's exactly what we're looking for. So the base address, i.e. the point that is the base for this particular thing, is the result of a virtual alloc call to page execute read write, which is fabulous. That's really good to hear. Because that means that we can treat that H module as a pointer and just call virtual free. But before doing that, what do we need to do? We need to clear out the memory. Okay, so forgive my little sojourn into something that was clearly a little bit messy, but effectively what I wanted to do was make sure that the reflective loader, when it runs, it actually returns a pointer that we can then refer to as a valid memory address for freeing. Okay, so that means that we don't necessarily need to unload. In loading everything up, all we're doing is allocating a massive block of memory, and we're wiring in a bunch of stuff. Function pointers, we're relocating, we're mapping sections to memory, we're doing all of that kind of stuff. But the important thing is at the end, it's just a block of memory, right? So as long as we can guarantee there's no code running in there anymore, we should be able to just clear it and free it up. The only problem that we've got is we don't currently have the ability we don't have the knowledge of how big the area of memory is that was allocated, right? So the reason why that's important is because if we're going to scrub it, we need to know when to stop. So in the reflective loader, you can see here, when it does the virtual alloc call, which is, sorry, I scrolled too far again. Virtual alloc. Here we go. It's doing this. Optional size of image. So we don't actually know what the size of the image is. That's an interesting one. So how are we going to figure that out, given that the result of reflective loading is a pointer to a block of memory, and we don't know how big that block of memory is? The first thing that comes to mind is, are we going to abuse knowledge of what virtual alloc does and fish out the size of the block at that point? Or are we going to try and keep track of it ourselves? The former is appealing but dangerous, because virtual alloc might, I don't know, it might change depending on the environment that you're in. So virtual alloc's metadata might be different on Windows XP as compared to Windows 10. I wonder if there's a way of figuring out using something like virtual query. Virtual query. Let's have a look at what virtual query does. Come on, internet. Okay, the size of the buffer. Okay, so I guess not. What is it going to give us? Retrieves information about a range of pages. Retrieve information pages address space of another process. No, we don't really want to worry about that. Okay, so that's only giving us detail of, yeah, it's only giving us the detail of pages that we're actually asking for. It doesn't actually tell us how big that particular blob of allocated memory was. Continue report map or whatever. Here we go. To detect whether copy on write has occurred for a specific page, access the page or lock it using virtual lock function and make sure the page is resident memory, and use query working set to check shared bit extended working set information for the page shared. Yeah, that's not going to use, that's not helpful to us at all. So what we're trying to do is there a way of determining how big an allocation was? That's effectively what we're doing. So let's do some very crappy Google. You know what? Let's not do that for now. What I'm going to do instead is I'm just going to free it up. We'll start by just freeing it up. Okay. What do we got here? Oh, jeez. A little bit confusing. I'm hoping not, Kilo. Just let me know if you have any problems understanding what I'm saying. I'll try and explain a little bit better. Thanks, Parks. You're a legend, mate. Windows Meterpreter, YOLO certificate checking. That's true. Paranoid mode does change that. So unrelated to the cool stuff OJ is doing at the moment. Okay, I'm going to skip that. Here's an idea. Is the original PE header still mapped to memory? And probably is. You could grab the size of the image back. Exactly. That's exactly what I think I'm going to have to do, in the same way that the reflective loader actually does that. it actually copies the header over in the first place, right? So, sorry, I'm clicking over. Let's go back to that reflective loader. So the first thing, once it's done the allocation, okay, so we do the allocation, and then the first thing that we do is copy over the headers. So it's already there. UI header value. We must now copy that over. That points to the beginning. Hang on, where are we? The base address, that's what we've just allocated. And the first thing we do is we copy over, where are we? While, aha, right, so that's how big. Size of headers. And then we start at the base address from the library address. Where's the library address? Get the VA of the NT header for the P to be loaded. Question is that library address the one that contains this header value? Aha, yeah, it is. Okay. P-image DOS header. If we cast that to a DOS header and add that value there, then we get the header value. And that's what we're using to cast to an NT header. So I wonder if we can actually figure that out on the fly here. So what we need to do is we need to do something like dword. We'll go get, I'll just call it get reflective DLL image size. And we'll give it the H module. I think that's what this was. Yeah, H module. H module. Ugh, can't type tonight. DLL. Actually, we'll call it reflective DLL. So we've got a reference to the reflective DLL. And we know that at the start of that, it's going to be this header value here. UI library address. Oh no, it's the UI library address, which is this thing here. Okay, so that's the start. And so what we want to do is we want to add whatever that address was. Cast this. Okay, so we need to take whatever that is, because this is going to be copied, isn't it? Yeah. We get given this library address, or do we? No, we don't. Yes, we do. We know the start, because library address is effectively the start. Okay, so we have this, and we want to offset it by this. Okay, so let's take that. So reflective DLL, I'm just going to do the thing that you generally shouldn't do. I'm going to cast that to a ulong pointer. I'm going to call it the base address equals ulong. We have to use the pointers rather than just ulong, because in 32-bit, sorry, in 64-bit it'll get truncated, and we don't like truncation problems. We've had problems like that in the past. We really don't want to do it again. Okay, so we can say we've got the base address. Okay. So that gives us the offset from the base address, and that will give us the header value. And from the header value, we can cast that to an NT headers and get the optional header size of image. Okay, so we cast that to an NT headers with an offset. Okay, so we've got to take that and add it to the base address. Yeah, and from there we've got optional header size of image. Boom. There we go. How nice. So that was actually a little bit easier than I was expecting, especially given that these things are clearly already resident. That's cool. Okay, so we need to go dword image size equals get reflective field image size finder.extension.library. Excuse me. Okay, so let's go. Module %s is I like to do it in both unsigned integer and hex. If I can type, it would be in hex. Senex. So we can go image size, and what was it called again? Extension. All right. So that'll hopefully give us an idea of how big it is, whether or not we're actually on the right track. And then we should be able to do 0 memory, because it's read write X. 0 memory. Let's cast this to, oh, we don't need to cast it at all, do we? We can just pass it straight in. So that's finder.extension.library. And image size. So we should be able to 0 the entire block, and then we should be able to call virtual free finder.extension library size, image size, free type. Isn't that just like mem? It's the opposite of this. Mem. Yeah, let's just do that. I don't think there's really anything else I care about. Let's just check what we should be doing here, because I don't really like stabbing in the dark. Virtual free. And while we're here, we'll do virtual alloc and just have a look at the flip side, because it will have some documentation on what it is that we should do when we free stuff. Page execute access, examples, reserving committing memory. Let's have a look at that. Mem commit. Virtual free, there you go, decommit the pages, mem release. Of course it's mem release, what am I talking about? The reason why, Justin, that I'm not using size T is because virtual alloc and virtual free use dwords. Mem release. Okay. So that frees that, and then finally, what we need to do is we need to free the finder extension, because that was actually allocated using malloc. So yeah, let's just do that. So unload, clear, setting memory to 0. This will give us an idea, like if something crashes, we'll know exactly which point. Freeing up the image's memory, and then finally freeing the extension pointer. It's ugly, I know, but you know, what are you going to do? So that rebuild. What's going on in chat? Virtual query sounds like a good idea. I was hoping virtual query was actually going to give us a bit more info, but it was just looking like it was going to give us flags on pages. Hey Jeff, how's it going, mate? Justin, oh, you linked. Yeah, thanks, Justin. That was the first truncation pane. Trying to learn to use. Yeah, so the only reason I chose dword was because that's what the function signature was using, and I knew that was going to be the case, which is why I jumped straight to it. And yes, you're right, Mongo. It's definitely stuck at 32 bits for the PE header. Size T is going to be 64. That's right. Exactly that. Exactly that. Dword's always 32-bit. Dword underscore pointer is the same as size T. How many bugs is that an issue outside of virtual alloc? Yes, actually a bit of a mindfuck, and this is so true. This has been a cause for a number of bugs in Meterpreter as well. So it wasn't just the pointer truncation that caused headaches in migration scenarios, but there were various parts of incognito that were ruined, and there were so many counters and function pointer arithmetic based functions that were broken horribly as a result of using dwords instead of dword pointers. So yeah, it's glorious. All right, that's succeeded. Let us do this, exit, and we'll kick off another session. Where is my, I've got to minimize that. Kick off another session, let that spin up, get rid of all of this gunk. Okay, all good to go. Let's spin up a new one. Watch the magic happen. I expect this to crash, just so you know. I'm not expecting to see this work beautifully the first time. That effectively never happens. Oh, I've got 2 sessions. Let's get rid of that first one. Okay. Let us use, what are we going to use? Decided to use another one for some other reason. Oh yeah, let's use PowerShell again. IRB, and let's drop in and unload priv. Aha, that's a good sign that something's crashed. See that? It's died. Calling dinit. So this time, this is interesting. This time it actually failed on dinit. Why is that the case? It definitely crashed. And have we got, I don't even see an error. I don't even see it appearing. So calling dinit is where it failed, which is interesting because calling dinit on it before didn't result in the same failure. I am wondering whether or not that's because we just removed an extension that wasn't at the end of the list. So let's do it without loading PowerShell the first time. And we'll go from there. This could actually mean that there is some kind of command handling functionality that's busted, which we may actually need to fix. Let's go and do that again. Success -1 and IRB. Oh, it's going to break again. Call dinit. Okay, so I've clearly done something a little different. So we called dinit on the remote, and that actually worked last time, didn't it? An extension attempting to unload priv. Yeah, okay. Enumeration result, blah. Found extension, removing it from the extension list and calling dinit. Ah, that's actually something that maybe it's because I did this first. Yeah, I wonder if that's it. Okay, let's take this. First of all, I'll leave that as a found extension. I'm going to move this down to here, removing it from the extension list. Okay, let's see what happens. happens here. Yeah, I wonder if that's the problem. So let's build that up again. Interesting. Gotta love these order of issue kind of things. Hey, if we go back through, we'll probably notice why. Where's priv? Deregister all. Yeah. Where is it? There it is. And so, command deregister. What is it doing? Aha, extension command. So it is. It looks like it is looking at something that's related. So, okay, well, let's give this a go anyway and see what happens. Okay, so exit out of that. Make install C Windows, and let's kick off another session. Okay. Roll and oh, it's still crashing. Removing it from the extension list. So I wonder if for some reason that these two things are mutually exclusive, because it looks like when we do one or the other, things break. How fascinating. Righto, so call deinit, and that succeeds. And then when we call list remove, it fails. Oh, hang on just a minute. No, that's not necessarily the assumption that we can go with. It could actually be failing here, right? Let's check this out. Looking for the DLL image size. Let's add that little message in there to find out whether or not we are. Hang on. No. Stop. Let's go back to that. Okay. Building again. What's in crash? Is it crashing on the line below? Yes, that's a good point, Jeff. And that's exactly what the conclusion that I came to, but later than you. So thank you for that suggestion. C is awful, isn't it, hey? Okay. Let's kick it off again. In all likelihood, it is crashing on the line below, given that it's not very safe code, to say the least. But yeah, let's have a look. Back to Metasploit. Let's go. There you go, looking for the DLL image size. That's the problem. Okay, so we are clearly doing something strange in here. And it's not very happy about it. Remote dispatch. Let's go back to the reflective loader. Base address is what's returned. So base address is not modified again. All the way down to here. So we cast that to an H instance and call process attach, which means when we attach, we set the app instance to effectively the pointer. And then later on when we query the module, the app instance is passed back out. So that is definitely the pointer that we're receiving. Okay. Yeah. That's interesting. Okay, so we're definitely getting the pointer to the area of memory that's been allocated for such a thing. The question is, are we Are we doing something awful here? So let's add some debug output. So RDI size sent. I could probably refer to this as a pointer, couldn't I? Yeah, let's do that. Alright, so there's the base address. Let's take this little bit here and we will go long pointer. Yeah, let's call that ELFAU. Do the same here, but we'll do X here instead. Just get some horrible debug stuff going on. So that means we're going to need to do an offset. So that is an offset to the optional header. So opt header equals base address plus new opt header all the debugs. So from there equals p image nt headers. So we're casting that opt header. Is that what? No, that's not what I'm doing. That's an nt header, not an opt header. So this would be the opt header. We'll use long pointer again equals whatever the nt header is, optional header, and we will pass in the address and cast that to the long pointer as well. Pass this in here. Okay, so then finally, dword image size equals what is this again? This is the image what does this return? Ah, right, an image optional header. There we go. The image optional header. And we're going to cast that and pull out the size of image. Okay, image size is %x. Let's just go with that. And we'll be returning image size. Yuck. How many people I got with me? 40, that's not too bad. No more chats. If anyone has any questions, now's the time to ask while I continue to fumble around why this is causing problems. Okay, that's all good. Install, exit. fire that up. Okay, let's see where it's busted. Oh, check that out, it didn't crash that time. Would you look at that? There's the base address. That's where the NT header was. Image size, priv. I must have done something particularly stupid when I did all my casting or something before, whereas clearly breaking that down, it looks like it's doing the right thing now. Go figure. Got a question, OJ, why did MS name the offset to P? Yeah, that's a great question, mate. I have no idea. Absolutely no idea why they named that. No idea. In fact, I'm interested to know. But yeah, it's not something that I've actively researched. Jardeth, bedtime. Thanks, Jardeth. Appreciate you coming along, buddy. Cheers, mate. Definitely see you in New Year. Sabaru275. Yes. Fire away with your question, my friend. Happy to answer you. Okay, well that's very interesting because everything that we just did has worked. So we figured out our size, figured out where it was in memory, and we set it all to 0 and we freed it up and nothing appeared to crash. So that's interesting. Is it fair to assume at this point that things are actually behaving as we would expect? I don't know. I'm wondering whether or not there was some... my feeling here is that there was actually a bit of truncation going on somewhere. Maybe... maybe... Oh, no. I was thinking maybe if this was just a long and that was 32 bits. But we are in 64-bit land, so there should be no... Oh no, that could still be truncated. Wondering if for some reason there was a type coercion going on without actually forcing these things to be of certain types at every step of the way. Yeah, but clearly that seemed to behave itself. The only thing that we haven't necessarily validated so far is that the image size is exactly that. We can validate that though. Let me just see if I've got some tools here. No. I'm going to do something that you're not necessarily supposed to do. I actually would, hey Mongo, would Ida be able to tell me the image size? You answer that? Yeah. Okay, let's quickly look at. Just had to sign up first. How did you get to this point? Is this a shell injection of a process from exploit? And how are you trying to prevent to root or administrator on Windows with a pointer you found from what? To buffer overflow exploit? And the pointer is to some kind of system object that gives you access to admin functions. Okay, so the short answer to that question, Sabaru, is none of the above. We're not actually doing any exploitation at the moment. The assumption here is that we've already exploited something. We've got code execution. We've run some kind of remote access Trojan. In our case, we're using Meterpreter, and Meterpreter is running. And so you're able to interact with the rat as a post-exploitation tool. So from there, we have the ability to do all kinds of interesting stuff. What we're trying to do at the moment is do the opposite of a feature that's been in Meterpreter for quite some time, and that is loading extensions. So we want to unload extensions and scrub memory so that they don't exist anymore without actually breaking things in the process. So that's what we're in the middle of now. We're not actually doing exploitation related stuff. Yeah, Mongo, Lord PE is a bit of a classic of mine as well. I was going to use PE ID because I'm pretty sure that has it. Where's the download button? First byte subsystem. Maybe it doesn't have all of the entry point size of image. There it is. Awesome. So where's the download? Go to download. Okay. What could go wrong? Yeah, whatever. Just give me the zip. I like to live dangerously. There it is. I have actually used this a number of times. Lord PE as well. I think that was on an old VM. EID. Just drop it. It's a good thing that this machine ultimately doesn't matter. But I wouldn't condone doing this in normal circumstances. Alright, let's open up. It is share folders, code, Metasploit payloads, C Meterpreter output, x64. Now an X server priv is the one that we're currently running. So, well, check that out, eh? It's not a valid PE. I don't think that's true. Let's drop this on the desktop so that I don't have to go searching for it again. Don't need that anymore. PA. Yeah, it really thinks it's not a valid PE. That's fascinating. Okay, well, let's go and grab Lord PE and see what that says. Softpedia. That's pretty interesting. Of course, harmful programs. For some reason, Lord PE has been for some reason deemed to be malware. I'm pretty sure it's probably going to do something that no, don't block it, Chrome, you jerk. Unconfirmed. I want it. Leave me alone. Just give me 1 sec. Just gonna do something off screen. Just grabbing it on a machine that doesn't care. You can imagine what that means. Okay, let's see what this does. There it is. P32 plus. Ah, that's why. It's actually not happy with the 32-bit version. Okay. Well, we can solve that quite easily. Let's flick this over to Win32. That would probably be why PEID didn't work before. Now, just so you know, when you've been working in 64-bit land, you got to clean it all up before you rebuild. Takes a little bit of time. So we may have to have some chats while this is going on. What do we got here? Lord P is not fave. Jimzo, when is your next stream? My guess would be in another 2 weeks' time. We'll be after Christmas by then, so I'll be keen for the next one. Sabaru, thanks for the answer. Related question. My boss said he knows remote ODA exploit for Win 7. Do you know of such exploits for Win 7 or 8 or 10? I don't know of any off the top of my head, but I have zero doubt that they do actually exist. So yeah, I would say they're out there. They're definitely out there. And you can probably buy them in a nice packaged executable format. Mongo, yes, it's about every 2 weeks. No need for apologies. Not a problem at all. You keep asking those questions, mate. It's no problem. Justin, if I had a Windows remote, it wouldn't. That's probably true. But yeah, I would say that there's definitely 0 days out there. And the shirt off my back that people have Windows remotes. Yep. Jimzo, yeah, Justin, I'll let you answer those questions. Woman, yeah, legit links. Love those. Kilo, yeah, I didn't use Internet Explorer. I just went to wget on Linux, which literally doesn't care at all. Finished PGP, yeah, Justin, you need to get your streams happening. And yeah, that's pretty much it. So the compiling of these things out of the box is still a little bit slow. And unfortunately, there's still one extension that I can't build cleanly, and that's the Python extension. That's because I flat out refuse to go through the Python extension source code and get rid of all of the compiler warnings. But all of the other extensions in Meterpreter should build cleanly for you if you're the kind of person that wants to build your own. So with that said, that means I'm going to need a 32-bit TCP, which I have sitting here. Let's just make sure it's small. Yep. So that will get me a session. I can start using that instead. But more importantly, I'm going to need to copy the 32-bit DLLs out when they're finished loading, building. So what we're going to look at is prib. And that was built on the 20th at 10:54, which according to this machine is now. This machine's on a slightly different time zone. Okay, so here we go. Current file size. Where is it? Did that not actually? I've got to open it this way, don't I? Right, size of image 22394. I'm also going to open this in PEID and see if it's any different. Okay, so what are we looking for? We are looking for subsystem 22394. There we go. Okay, let's see what it says. Assuming that everything's going well and the compilation has finished. There you go, all rebuilt. Let's go back in here. Exit out of that session, copy the binaries over. Let's get a 32-bit session running. There we go, got our warnings for our 32-bit binaries that have just been loaded. There you go, it's a 32-bit Windows. Now before I unload that, let's just make sure we've got this running and clean. Didn't crash, so. Alright, so image size set to 23000. So that's not exactly the same, is it? Did I accidentally close that? Oops, that's not what I wanted. Okay, so 23000. I wonder why that's the case. Clearly it is. It is very slightly bigger. I wonder if that is for some reason rounded up. I honestly don't know. I would have expected the image size to come out exactly the same. It's certainly page aligned, which it would have to be for virtual alloc. But yeah, I'm gonna go with it. I think it's clearly bigger. It's better that it's bigger than it's smaller, and it's certainly within the same ballpark. So yeah, I wonder if there is something in there that will answer that question for us inside the reflective loader. I don't think there will be, but it's certainly worth looking into. Image base. Data directory, check if there are any relocations present. So where was it again? Size of image. That's the first reference to it. So for some reason, that size of image is different. Why would that be? I honestly don't know. You got any ideas, Mongo, Justin? Anyone else? Yeah, thanks. The edit button instead. Yes, I think I learned that the hard way as well. No Kali. No, we the Red Ninja. No, we don't need to use Kali here. I'm not a heavy Kali user. We're just adding bits and pieces to Meterpreter at this point. Okay, so what I'm going to do is I'm going to go back to where we were sitting. I'm going to close all of this off, except for the one file that we've currently got open. And I'm going to go with the fact that this appears to be doing predominantly what we want it to do. There is just one key difference now, and that is on the Metasploit side. We need to make sure that we lose track of the extension. That we've just unloaded. So what I'm going to do now, I'm going to change this to error success when we actually locate and unload that extension. I'm going to say that all worked perfectly. But in the case of not, we're going to go error. Is there a not found? There you go, an error not found. Is that really what we want to be doing? Yeah, let's do that. And I'm just going to let that rebuild behind the scenes. So the reason why I want to do that is so that in here, when we get this response, if it comes back okay, then what we want to do is we want to say, okay, we've come back with an error success, which implies that the extension that we've just attempted to unload is no longer present in the target. So from there, what we want to do is locally, we want to do the reverse of wiring in all the client stuff, which I think this is probably the scariest part of all of this stuff for me, because the Ruby side here is particularly unclear. But hey, let's go with it and we'll see what happens. Did I get rid of yeah, I did. I might just leave that in there. So when we call use, like I said, we have all these commands, right? And we keep track of them in this add extension. So let's have a look at what add extension actually does. So from here, I'm gonna exit out of Metasploit, and we'll look for def add extension in the lib folder. That's in Meterpreter client. Okay, so Meterpreter client.rb, there it is. So add extension. So what are we doing here? Check to see if this extension has already been loaded. And then what do? We require, so we effectively include the extension on the fly. And then we create, where are we? Name constants added. Yeah, that's okay. So it's doing some magic with constants, and it says save the module name to class association now that the code is loaded. Create a new instance of the extension and get rid of it. Okay. Okay, that's cool. This doesn't look too painful. So if we do the, ooh. Would you look at that? It's got a deregister extension. Aliases.delete name. No way. That could make it super, super easy. Okay, let's just do a quick grep for deregister extension. Oh, wow. It's not actually used, but it's sitting there. So that calls delete. It could actually be that easy. How exciting. Register alias. Okay, so if we go back to here, this add extension, and we've got this, all we need to do is go client.deregister extension mod. Wow. I wonder if that's all we need to do. Now, if this fails, this send request fails and you don't actually get a valid error success response, then it effectively throws an exception behind the scenes and this doesn't get executed. So let's kick off Metasploit again. I'm loving this guy, Baroni sounds awesome. Alright, so our binaries are built. Get rid of this stuff now. Get rid of that stuff. Binaries are built. Copy them over. Alright, let's do this thing. Okay, let's go. We'll load a separate one this time. Let's load Espia and IRB. Unload Espia. Here we go. Ooh. So that's interesting, isn't it? Ah, but you see the Espia commands are still in here. What happens when you try and run them? Well, at least you get the request not supported, but that's clearly not what we're looking for. I mean, if you look here, this is debug output for command dispatching. You can see attempting to locate Espia image get dev screen. Can't find it as a base command, and then it looks in extensions. Can't find it in extensions, and it just says, hey, not found. So we're behaving perfectly on this side, but that deregistering of extensions didn't seem to do what I was hoping it would do. I was looking for an easy way out, and clearly that's not what's going on. So let's have a think. What are we doing? We're deregistering that. This alias is, so only deletes an alias. That's not necessarily as. Save the module name to a class association now that the code is loaded. Okay, so if we type question mark into this, let's have a think. We need command help, don't we? So that would be probably in client core. Maybe not. Let's just do another quick grep. And help. And lib. So. Yeah, there it is there. It's in dispatcher shell. Okay. UI text dispatcher shell. Command help. I love this. Alright, so what are we doing here when we iterate through these things? We've got a reference to a dispatcher. It's looking through each of the functions. Where are we? We didn't find a command, try it as a dispatcher name. Okay, so this is clearly where it's actually dumping stuff. My guess is didn't find a command, tried as a dispatcher. I don't even know what dispatches are in this particular context. Let's have a look. Command, dispatcher stack, help tabs, prompt. Okay, so this shell clearly looks like it's the Meterpreter shell of some kind. Rex, post, Meterpreter, UI, console. Aha, here we go. So this is a dispatcher shell for sure. So it's including that dispatcher shell as a module / mixin. And then Q command. So it does have a bunch of commands. No, that's not what we're looking for. It looks to me like the commands that are associated with what people are actually doing. There's not a lot to this on top of what the dispatcher shell actually does. So I would assume that, here we go, this is where it's actually doing the dispatching of commands, and run single I would assume would be in here. Here we go. Yeah. Gotcha. So here it's saying, do you have a commands array? And so commands delete if. Yeah, yeah, okay. So these are the commands that looks like it's actually executing as people type. Q command. Yep, there it is there. So that's it. So like if I type in something like help, it adds it to the queue, and then later on it's actually pulling these. There we go. Interact, run single, and run. Here we go. Run the interactive loop, run single for each line. That queues the command. Yeah. Okay, so it parses it, handles the arguments, looks at for each dispatcher. If it doesn't have commands, begin, does it have a key, blah, blah, blah. Okay. So there's something in here that we need to muck around with. We need to find out how it's keeping track of the commands. Just quickly go back over to here. Rebuilding thing, maybe changing the image size field. Yeah, I agreed, but Mongo, I was looking at the exact same binary and it was pretty unlikely that it's going to be bang on hex 23,000, so yeah, who knows. Image size does already include the size of the headers, yes. Wondering how you got started in just research specific course or traditional schooling. Spammy the pig. How did I get started? I got started, this is a very long story, I'll give you the short version. I was privileged enough to be given a Commodore VIC-20 when I was 7. And from there, it was all about the code. All the way through primary school and high school, I was just learning about machines, and then I got a sniff of security and reverse engineering during university, and the rest, as they say, is history. So yeah. This is why I was saying the effect in that field. Yeah, I'm pretty sure that that's not the reason why that field value is changing, Mongo, but yeah, we'll see. Yeah, the help command is hilarious, isn't it? Yeah, and he just discovered that one. Yeah, I think that was Egypt's doing, but I'm not sure. We'll have to see. Right, so welcome to watching me flap around in Ruby land, because a lot of this stuff here is very alien to me, and I'm really not sure where this stuff ends up, and it's not particularly intuitive to try and figure it out either. So let's just go back here again. When we add an extension, that goes to client core, client add extension. Here we go, check it. Self commands. So we add the list of commands to it. Right. That's interesting. So that tells us what commands are actually supported. Check to see if this extension has already been loaded. So I missed that when we first looked at that. Sorry about that. And then off it goes and does its thing. Deregistering extension alias. Okay, so that's only deregistering an alias, not the actual thing itself. Okay. Save the module to a class association now that the code is loaded. Okay, so this is only loading things if it absolutely has to, then creates an instance and passes in a reference to itself. Okay, so that means at the point that we load an extension, so let's open one of the extensions, priv.rb for example, given that we're actually looking at priv. Okay, so this is what happens. We register ourselves, client.register extension aliases. So we're saying priv points to us, and that is something that actually wires in things behind the scenes as part of core. That I don't think says wire these items into the menu. That happens elsewhere. So, for example, if we look at the command dispatcher for priv, see it here. Okay, so this is where the commands for priv come in, right? And then there's a bunch of them underneath that. So command priv, we'll look at elevate. So here you can see here's where the magic get system command is actually wired in. Right, so it must be that these commands get wired in for each one of those things that's actually loaded. Okay, so going back to client, that creates a new instance of the extension. So this means that, we've got to go one level up. That's our problem. We have to go one level up. So, unload, def unload. So, we need to be able to bubble one level up. We're actually not even operating at the right level here. So let's just return true. And then from here we need to go back up to the command dispatcher. That is part of command dispatcher. I think core is what we're looking for. Command use is the same as command load. Right, this is where we need to do it. So def command unload args. So what's going to happen here is if args.length doesn't equal 1, we basically want to say, let's move this up here. We'll go command unload help. This is the convention that we tend to follow. So def command unload help, and let's basically do the same thing here. We don't need the extra options. For now, I'm just going to say that we only support one, right? Unload. That tends to be optional, doesn't it? So, oops. Try and get the conventions fixed as well. Let's do that. There we go. Usage unload extension name. Loads of Meterpreter extension module. Modules command unload. Okay, so if that's all good and we do have an arg, then what we can do is we can say client.core.unload args 0. Now we're going to have to do way more than this as far as proper validation of arguments is concerned. But we can say if that succeeds, then we want to do the opposite of loading. So check this out. Each of the modules, extensions that include. So here we go. Extensions is the thing that contains everything that we're doing. So add extension client. Aha! Here we go. MD. Right, so what we need to do is the opposite of this. Def unload extension client module name. Okay, so I'm going to plug that in up here. Unload extension client args 0. Messy, yes, I know, but that's what we're going to do. Okay, so what is it doing? It is searching and it's adding a bunch of stuff at the top level. Command dispatcher set hash path class. So here we go. It's doing something what looks to be very similar to what we were looking at before. Nstack dispatcher extensions mod. So first of all, we can probably go self.extensions. We should probably check to see what that is. It's probably just a list. Yeah. Okay, so off the top of your head, who knows how to remove an element from a list in Ruby? Remove element from list or array. How can I delete one element from array by value? There we go. Dot delete. Easy peasy, hey? Okay, so let's plug that in. Self.extensions.delete mod. Is that enough? That's the question. Is that enough to make it all happy? The thing with this is that this nstack dispatcher looks to be quite interesting because we've got, look at this, nstack, look at that, dstack dispatcher. So we've got this nstack dispatcher, but we want to call this, oh, here we go, remove dispatcher. That's interesting, isn't it? Removes the display dispatcher instance. Sweet. Okay, so we want to do exactly the opposite of this. Remove the extensions, and then what was this thing called? Remove dispatcher. Could it be that easy? Could it be that easy? I'm excited. What do we got here? Yes, Egypt. Love that man. He is awesome. OJ, sub load, unload. Oh my god, it still says loads. Have I done something silly? Unload extension client. So I'm assuming you're not referring to this. Usage, unload extension name. Aha! Thank you. Unloads a Meterpreter extension module. Thank you guys. Much appreciated. Yep, got it. I'm in it. Thank you. Okay. Let's do this thing. Let's see what happens. So while this is spinning up and we're about to do it all again, ask yourselves the following question. Which thing is still missing? Of the stuff that we've discussed so far, which thing is still missing? Because I know there is still one thing that we haven't done which can cause problems. It's edge case stuff, but it can definitely cause problems. Whoever calls it gets a biscuit. Yeah, and help. Cool. Okay, we need a payload running, don't we? Go. Go on, folks. Who wants a biscuit? Okay, let's go. Use PowerShell. And as we can see, we've got PowerShell commands. Let's go unload this. Oh, this won't work. Unknown command. So what we need to do is go back to, so see how there's a load. We need an unload as well. Unload. Unload a Meterpreter extension. Now this is a little trick that you guys, may find useful. I don't know whether it's actually going to work or not. But you can actually drop in IRB and go load librex post Meterpreter UI console command dispatcher core.rb. And hopefully, there it is. So without having to restart MSF, you can do that. That's not what I'm looking for. Unload PowerShell. Let's live dangerously. Ooh. Ah, look at that. Oh, it died. It died. We've got bugs. Why did it die? Module PowerShell is 27 in memory. Freeing up the pointer. Interesting. Why did that die? I want to do that again. Did we scrub the extension memory? Yes, we did. Yes, we did. Yes, we did. Are we removing the commands before doing it, though? We are removing the commands before doing it. And we're trying basically to unwind everything that we've got going on. I think that deinit issue is going to be specific to PowerShell. And that's why that failed. So I may actually have some issues to deal with in PowerShell down there. That's interesting. I'm smelling something fishy here. That looked like the same session. Look, let's use a non .NET extension. Let's use, what do we got here? Let's go back to SPR. Okay, so the SPR commands are in there. Unload SPR. Okay, that didn't die that time. Yep, setting memory to 0. All right, let's see what happens now. They're still there. No. I think maybe it's got something to do with that list of commands that are associated with it in the dispatcher shell. remember when it does that sort of or equals. Now I've got to get rid of that dash v commands. Where is it? It's in here somewhere. There it is. So when we add the extension, we get those commands. But again, this is in extension land, right? So it's not so much of a problem at the dispatcher level, right? So let's just quickly go back to these things. The thing is, maybe, yeah, so screen grab and screenshot's still in there. So I think when we wire those commands in as part of the dispatcher shell, let's see, deprecated commands, command help, here we go. Yeah, so it's iterating through the response, dispatcher, command, whatever. Okay, right. Less command found. We didn't find a command. Try as a dispatcher name help for. Yeah, okay. Where is it actually outputting that from? Okay, so I think command something help. What am I missing, guys? It's not a bug here. Yes, I think you may well be right. But as you can see, we're uncovering some curlies in here. As always is the case, things are never as simple as they first appear. But what's clear to me is that for the PowerShell extension, let me just quickly fire this up, I'll show you. This is a bit of an ugly beast. The PowerShell extension deinitialize .NET host. I'll bet you this is where it's causing problems. Did we actually have an error message when it crashed the first time? Here we go. So I'm just looking through the log to see what happened last time. And here we were calling unload on SPS, so that's the wrong call. Can't find executing thread, core unload lib, executing inline, attempting to unload PowerShell. Aha, here you go. So clearing up .NET PSH runtime, removing from the extension list. That all appeared to work, didn't it? Oh no, then it died here. And then a new one spun up. So there, that did actually die, but it wasn't clear as to why that was the case, was it? Hey, that actually worked that time. No cleaning up commands. Yeah, it's fine. No, it's not fine. So there's definitely something going on with PowerShell that causes it to be very, very unhappy. I'm going to address that later by myself because I could spend a lot of time exploring that to try and figure out what's going wrong. That's one of those edge case bugs that's going to be nasty. Is the extension still working after unload, or is it just a display issue? Firefart. It is just a display issue. So what I want to have happen, well, at least if we ignore the whole PowerShell is crashing thing when you unload PowerShell, at the moment it's literally MSF side. So on the remote side, it's definitely removed, and I can prove that to you by doing the following. Let's spin up a new session. S-1. So what I'm going to do is we'll go, let's use incognito. Okay, so incognito gives me a list tokens function. So let's go list tokens -u, and you can see it's come back with some stuff. If I unload incognito and then do it again, you can see it says incognito list tokens failed, the request isn't supported. So on the Meterpreter side, it's absolutely unloaded and deregistered the extension. There's still issues in there, but it has actually removed the extension. There's other accounting that I haven't yet catered for. So the two gaps in the accounting right now are, I need to force the Metasploit side to unload the module that was related to the extension that we've loaded. That's one thing. And on the other side, I need to make sure that all of the extensions that still exist in memory are informed that each of the commands that were associated with the unloaded extension are no longer available for use, and that's going to take a little bit of time too. But other than that, we've done the bit that we set out to do, and that is properly unload an extension and sweep the memory that was associated with it, assuming that we're not doing that incorrectly. One thing that we could probably do better, let's see, as part of the RDI is maybe we could add some debug output that prints out the size of the image as it's being allocated. But yeah, Justin, you said you had a couple of questions. How does a sleeping session that phones back home inform MSF of which extension is loaded? Are extensions is marked as don't page me, bro? Should that be undone? Or do you get that for free when you free it? Okay, so the answer to number one is a sleeping session retains all of the extensions that it had before. When it connects back, what Metasploit does is it says, okay, I've got a new session, it's stageless, I know that it's stageless. And then what it does is it says, okay, I need you to show me this. Actually, hang on just a sec, let me show you the code for this bit. Load libpipe stand API. Oh. That's not what I wanted. Let me do it the other way around. That's better. Here we go. So base sessions. Base sessions, Meterpreter, standard API. Okay, so Justin, this is answering your question, I hope. As you can see, when we create a new session, this whole thing is wired in, right? This is a session object, and the session object itself is instantiated when the Meterpreter session is first connected and the metadata is all wired in. This loads standard API thing. I'm just trying to get the exact right reference for you. Meterpreter options. Okay, so when a new session is established, this on session is invoked and says, hey, here is the new session. Okay, and when that happens, this block of code is executed. Okay, and as part of validating, like setting up the session, the first thing that does, it says, are we by default loading standard API, which is on by default, right? So the first thing it does is says, okay, I'm going to load standard API. And that's what we were just looking at here. Load standard API basically says, I'm going to pretend I'm sitting at the console and I'm going to type load standard API, okay? And that's what it does. That takes us back to, I think it's client core, yep, where we end up with use, okay? Use says, hey, first thing I'm going to do before I actually interact with this mod is I'm going to go, hey, can you tell me what extension commands you've already got loaded? Okay, so we set up a request to Meterpreter and we say, I want you to enumerate the extension commands for this extension. So we're saying, here's an extension name, you give me a list of all of the commands that you have associated with that extension name. And so what happens is that's actually sent off to Meterpreter. Meterpreter will look at its metadata and go, okay, well, you've asked me for standard API. I've already got standard API because I'm pre-existing session. So I'm going to return a full list of the commands that I've got associated with standard API, and that's what gets returned here, okay? As a result, we go, okay, did you give me any commands? And if you didn't, right, that's what this says. Unless we actually have commands, i.e. if we haven't, then I'm going to go through, load the file from disk, and I'm going to send the extension down. After that, regardless of whether it existed or not, I'm going to wire in the client side section of that extension functionality so that I can now interact with it as far as Meterpreter and MSF is concerned, right? And that will work for every single extension. So if you had a session and you were using Extapi and then you changed transport, so you put it to sleep and it came back in, you would still need to type use Extapi again, but the actual mechanism that pushes the binary up doesn't get run because it determines on the fly that that's actually already in place. So that's how that works. I hope that answers that part of the question. The second question, how are extensions marked as don't pays me bro? Definitely. They all extensions that are loaded through reflective DLL injection have that thing that I was telling you about. Hang on. Library so that's not what I was looking for. I was looking for reflective load. Reflective loader, where are you? Inject reflective loader, here we go. .c. Okay, so the reflective loader is what's invoked. This thing here is what's loaded exactly every time the reflective DLL, as the DLL is sent up to the Meterpreter session, the reflective loader is invoked, okay? And so, as part of its reflective loading, we pull out a pointer to a function called virtual lock. And then as soon as we have allocated memory for that extension, we lock it. So that's what we're doing there, and that happens for every single one. Okay, cool. So the code is there, but your help won't be populated until you use it again or load. Exactly that. Mongo, gotta go FK. Catch you on the end. Okay, no worries, man. Thanks very much, Mongo, for coming along, buddy. Appreciate that. All right, so actually Firefart mentioned something. Is the extension still working? Yes, we've answered that one, haven't we? We definitely need yeah. Yes, we do. We absolutely do. And because I'm hunting in areas of MSF that I'm really not that clued in with, clearly I'm missing some obvious stuff. But the kicker for me is that right now, when it comes to help in, say, where are we? Priv's console command dispatcher, this privilege escalation section and all of these subsections here, these dispatchers, have their own help commands, right? So if we go back to elevate, where's elevate? These commands get wired in, And that name gets referenced by something. And that's what I'm trying to determine as part of this dispatcher shell. See this dispatcher? For each one of these dispatchers, so it's this stack of dispatchers that we need to muck with. There's no doubt about it. So each one of those does the tab complete, run single, unshift. So there, we definitely need to be able to remove a dispatcher based on the name. Adds the supply dispatcher at the end of the dispatcher stack so that it doesn't affect any and stacked dispatchers. Remove dispatcher. That's probably what we need to do. So there's this end stack dispatcher, which is there. Let me find out where else. Shell.stack. Okay, so it's end stacking all of its dispatches. So what we need to be able to do. What do we need to be able to do? We need to. Part of the problem here is that one particular module may have a number of dispatches, so we need to remove all of the dispatches that are associated with this particular module, this class. So we kind of stack up these dispatches, but we currently don't have the accounting in place that will allow us to track which dispatcher is associated with what. Right, so I think we're going to have to add some more tracking. So when we instack a dispatcher, what else do we need to do? We probably need to say, if we're instacking a dispatcher, we want to associate it with a name so that we can keep track of which dispatchers are associated with a module name. Okay, so let's see where instack dispatcher is called. Whoa, there's quite a few. And dispatcher modules. So it's not surprising to see anything here deal with it. But this console driver is an interesting one. Well, let's have a look. libmsf UI console command dispatcher modules. Alright, so instack dispatcher. What does this do? Ah, okay, so there's a dispatcher for the module that you're currently functioning with as well. Okay, that's interesting. So if we change the dispatcher such that this is concerning, because in Metasploit land, do we have a number of dispatchers internal to the Meterpreter dispatcher? Maybe we do. What am I looking for? I'm looking for Meterpreter UI console and stack dispatcher. Right, so okay, so this has its own set of dispatchers. Yes. Okay. So we can add an overload to this that is specific just to Meterpreter, because it's this dispatcher shell that's specific to Meterpreter has its own set. Right. Yeah. Yeah, it's interesting. Peeing horse. Why is the title so racist? It's not racist, it's just me mucking around. You want to talk about titles, maybe you should check your own. Right, so I'm thinking that we should change this nstack dispatcher, or have an overload that's specific to Meterpreter that actually does some accounting of dispatchers and their names, and so we can somehow maintain a dictionary per se of the dispatches that we're keeping track of, which I don't think is going to be that difficult. All we need to do is keep track of dispatches based on name. So self.dispatches, we're just going to have what is just a dictionary at this point. And so when we instack a dispatcher, I'm actually going to change this so that it's not in stack, it's something else. Let's go with add dispatcher. We'll call it add extension dispatcher. And so maybe what we need to do here is call that extension dispatches. And so here we've got the name followed by whatever that was. It was an actual dispatcher. Okay, so the first thing we'll do by default is actually call in stack of the actual dispatcher. Does that give us the dispatcher back? Yes, it does. Dispatcher new self. Okay, so we get that instance. And we can say if, what do we want to do? We want to go self.extension dispatches name. So whatever the name of the extension that we're adding, if that doesn't exist, we need to go and set it to effectively what is just an empty list. And then from there we can say self.extension dispatches name. We just want to append to the list, so I'm guessing append is all we need to do. So we want to add the instance of the dispatcher to this internal list. Okay, so from here what I'm going to do is I'm just going to call that core as a core dispatcher, and we'll call add extension dispatcher here. And so I think anything where we are and stacking dispatches that are specific to our Meterpreter shell, we're going to change it so that the dispatcher maintains the name. Okay, so we don't need to change what's in the dispatcher shell. We've already changed the Meterpreter console. We just need to go through and change it for each one of the command dispatches for the extensions. So let's do that. Where are we? First of all, let's go to command dispatcher extappy. Okay, so we've got this in stack dispatcher here, and that's pretty much all I can see with regards to extappy. So for each one of these dispatches, instead of calling in stack, we want to call this new function. I can't remember what I called it, add extension dispatcher. So yank that, do that, and we want to call this by the extension name, which is extappy. Okay, so let's write that. And we'll go to standard API and we'll do the same thing. Where are we? Command dispatcher standard API. So that's pretty much doing the same thing. But instead of extappy, it's standard API. Yeah, okay. Same story then with core. command dispatch core.rb. So that'd be in stack. Did I type that wrong? Console command dispatcher core shell dot n. I've got the wrong file open, haven't I? librex post UI console command dispatcher core. libmsf, yeah, that's the wrong one. We need rex post meterp command dispatch core. That's what we need. There it is. Okay, so, and this won't be, this will be add extension dispatcher class, and mod will be the thing that we're associating it with. Okay, so that's that. Now we've already got priv open somewhere. Is this it here? Yep. Let's go back to here and do the copy paste thing. And that's going to be priv. And then LAN attacks appears to be the last one. So dispatcher LAN attacks. What was this called? LAN attacks. Okay, so if we're able to do that, then when it comes to pulling it apart afterwards, when we unload, where are we? So we call add extension. Yep, so this isn't the one we're looking for, is it? It's under unload, command unload extension client. So we want to remove the extension. We don't want to remove dispatcher. We want to go remove extension dispatcher. So then we can go back to the Meterpreter shell. Where was that? Add extension dispatcher. Where is it? There it is. Def, yeah, remove extension dispatcher name. Okay, so the first thing we'll do is we need to iterate through and remove any dispatches that are associated with that name. So go back to there, dispatcher.stack. So we can destack and we can append. Removes the supplied dispatcher instance. Self.stack.delete if. So we have the ability to append. And that pushes things onto the pushes in front of the stack. Yeah, so effectively what we want to do is we want to call remove dispatcher, but we yeah, okay, that's what we want to do. Sorry, I think I've just nudged my microphone. If we went through each of these, assuming that there was, so for each dispatcher, we could go and call that function, remove dispatcher. Remove dispatcher d.name. So we're actually iterating through all of the dispatches associated with that particular entity and hopefully that would clear it out. And then we can just set that straight to an empty list, clearing it out as far as the metadata is concerned. And then we're done. Yep, I think that's pretty much it. Oh, I lost everybody? Everyone's still with me? There's people coming and going. Okay, let's give that a spin and just see what happens. Wonder how many errors I'm going to get as a result of doing this. It looks like it fired up okay. All right. Ooh. Undefined method extension dispatches equals. Ah. Do I need to put that in a, yeah. Extension dispatches. Yay, Ruby. Getting close now. I'm going to finish up pretty much as soon as this bit's done, despite the fact that we haven't yet got to the point where we're able to fully PR what we're doing, because I haven't added all of the checks. Haven't made sure that people are passing invalid extension names and adding tab completion. All of that kind of stuff. That's basically the story. So, right. Ooh. Append. Clearly append is not the thing that I was looking for. Maybe it's just a simple matter of doing this. Let's kill off that session. There's a couple of them still running. Still no questions? Okay. True. So I'm doing something very silly here, clearly. Self.extension dispatches. You can't append a true, so I must be doing something silly here. Alright, let's do this. Let's do that, unless... This is me sucking badly at Ruby. It's not taking too long. Chat has gone scarily silent despite the fact that people are still here. There are a few of you still paying attention. Alright, that's running. Let's kick off another payload. Okay, we have less errors. That's a win. Use SBR. There's the SBR commands. Unload SBR. Ah! It's gone! Yes! Yes, awesome. So if we unload Priv, Priv's gone too. use proof. Boom! Check it out. We now have the ability to unload and load extensions. And by the looks of it, we're actually clearing out the memory associated with it too. So that's fabulous, except for one thing, clearly. If we use PowerShell and unload PowerShell, go on, die. There we go. So unloading PowerShell is clearly a problem, but that's okay because that's specific to that extension. There would be other cases where that's possibly an issue as well, depending on what the extension actually does. But that's a bug in the PowerShell extension. But the exciting thing is that we now have the ability to unload extensions, and those extensions are properly scrubbed from memory. What we do need to do, so here are the things that would be left on the to-do list. We need to make sure that each one of those extensions correctly unloads when we call it. We need to make sure that each one of those extensions, when they unload, we track the commands and tell all of the other extensions that are still around that those commands no longer exist, so that integration points correctly throw errors. And finally, we need to make sure that when we unload extensions, as we're tearing them down, as part of the whole Meterpreter instance shutting down, that this whole process is also invoked, because at the moment it's not. I'll show you just quickly where that is. So that would be in, where are we? Server setup. Okay, so server setup. So as you can see, this is where we load stageless extensions, and going through the process of once we've got this dispatcher running. So inside here we'll have new extensions loaded, and then at the end, what are we doing here? We need to get rid of extensions. Let's just make sure. Server setup win, transport dinit, extension dinit. Here we go. Deregister dispatch routines. So that's getting rid of all of the extensions and getting rid of all of the commands, and then destroying the extension list. What we need to do is go through each one of these extensions, and instead of just calling dinit, we need to free the extension. So instead of calling list pop, what we're probably better off doing is going through the list in reverse and ripping it all down. And the best thing to do there would be, let's have a think. We could probably enumerate through the list, but the problem that we've got there is if we enumerate the list while we're tearing it down, we have some interesting issues. So yeah, this effectively needs to change so that it actually, instead of just calling dinit and then free, we properly unload it. Let's have a think about how we can do that. Yeah, what we can do, we can call list pop. No, we don't even want to do that. We just want to get the head of the list. So list list get. Yeah, so we can go while list count of G extension list is greater than 0. So while there are extensions, we can go list get 0. We can get the first one from the G extension list. Okay, and that will give us an extension. Right, so that will give us an extension. We should always get data back. So from here, we should be able to go unload extension, remote extension name. Now all the custom commands, yeah, so we can get rid of the custom commands separately as part of unloading each one of those extensions. And then we just destroy the list. Easy. Well, hey. Oh, thanks, Justin. Why Vim in 2016? We could get into an editor war at any particular time, but Vim is my favorite editor. It's the one I'm most productive with. That's why I use it. And because I'm yet to see an editor that's better for me. Vim is indeed timeless, Justin. I agree. Never. Good job. Thanks, man. Appreciate that. Or lady, if you are a lady. But yes, I'm pretty happy that that turned out the way that it did. Do the privesc commands work yet? I'm not sure I understand what you mean, Sabaru. Privesc in Metasploit are host modules and local exploits. They're not actually part of Meterpreter per se. Meterpreter is just the avenue in which those exploits would run. I think he means there is already NeoVim out there. Well, you know, there's MacVim, there's a bunch of Vim implementations, but the point is that, you know, Vim core, as far as an editor is concerned, you know, is timeless. Plus, I don't know whether you've noticed, but I'm using Visual Studio here, and that has I've bought something called VIMU, which is a Vim emulator that plugs straight into the studio, and I've supported the developer of this for a very long time, and I will probably continue to do so. So it's a paid extension, but it's worth every penny. All right, let's do this again. Make install. Now what I'm going to do this time is I'm going to try and shut this thing down without it dying. So let's create, this is the last thing I'm going to do before I sign off. So I'm going to spin this up, get rid of all of the debug output. I'm going to load up a non-killer extension. Let's use incognito as well. And from here, I'm going to just type exit. Right, let's see what happened. There's a few calls in here that make me happy, look. So we've got, where are we? Deregistering dispatch routines, attempting to unload standard API. Unload module standard API is there. Unload freeing up memory, unload priv. Unload Espia. Unload incognito. Finish what you're doing. Scheduler destroy. Finished. Exited cleanly. Yes. Awesome. All right, there we go. We're done ski. Yeah, we're pretty much done. So the only thing now that I would need to be concerned about is making sure that all of the extensions do get destroyed cleanly when we exit. We need to make sure that the Metasploit, the Metasploit side is definitely dealing with that accounting correctly. And finally, there's one other thing that I haven't mentioned here because it's actually a little bit of a bane of my existence, and that is actually getting Meterpreter itself, so MetServe itself, to be unloaded and scrubbed. But that's beyond the scope of this stream, given that we've already gone for 3 3/4 hours by the looks of it. So I'm going to call a halt there. Thanks to everybody for their attention. Ping me online if you have any questions. You can hit me on Twitter, you can drop me an email, all of those sorts of things. If you have any Meterpreter specific questions as well, let me know. If there's something here I haven't covered very well, then let me know. But that's it. I'm pretty much done. Thanks for your time. Have a good one. Chat to you later.